Hello, everyone, and welcome to this workshop on the impact of digital technology products on consumer product safety, jointly run by the OECD Working Party on Consumer Product Safety and the OECD Working Party on Artificial Intelligence and Governance. My name's Will Creswell. I'm the Deputy Chief Executive for the UK Office for Product Safety and Standards and Vice Chair of the Working Party on Consumer Product Safety. I'm delighted to be opening the workshop with you today. So why are we doing this? The digital transformation has profoundly reshaped the consumer marketplace globally. The integration of digital technologies such as artificial intelligence, AI, the Internet of Things, IoT, and virtual reality, VR, into consumer products has offered many benefits. This includes enhanced functionality, convenience, and importantly, the potential for increased product safety through innovative features like software updates and direct communication from manufacturers with consumers. However, these technologies also bring new challenges for consumer product safety, such as malfunctioning of devices due to software updates, loss of internet connectivity, or corrupted data, as well as physical harms from wearable IoT devices. Some devices may also expose the user to new risks after autonomously learning from inputs not necessarily controlled by the product designer. AI products may also need to be recertified after being put on the market as they develop new functions, raising liability questions as to who should be responsible for this. Other developments have led to a widening of the product safety challenges, including emerging or increased risks to consumer mental health. For example, in some circumstances, virtual reality video games have been found to have effects on cognitive ability, including memory loss. The replacement of human contact with autonomous products for older people may also cause mental health issues. Previous work by the OECD notes that existing product safety and product liability regimes may be ill-equipped to manage the new safety risks in the digital transformation. Risk assessment tools and data on the health and safety risks of digital technology products are also scarce. Preliminary results from a survey of OECD product safety regulators just last month highlighted in particular that in many countries, whether digital services or software fall under the jurisdiction of product safety authorities is unclear. Whether when several digital technology products are involved in an injury, such as third-party applications, causing a connected device to malfunction, attributing liability can be a challenge. Whether the product safety framework can address risks that do not relate to physical injury, but rather, for example, mental health, remains an open question. And responsibilities for addressing issues with digital technologies are often split across a range of different regulatory bodies, making it very difficult to know who's in charge. In response to these challenges, our working party has initiated a 2-year project to comprehensively assess the health and safety impacts of consumer products incorporating digital technologies, drawing on research, emerging risk assessment methodologies, stakeholder interviews, and exchange of best practices. It aims to identify gaps in market surveillance and provide practical guidance for authorities and indeed industry to better manage the risks. The focus will be predominantly on physical products rather than, for example, social media, and will exclude risks not directly related to consumer health and safety, such as cyberbullying. Today's workshop is intended to inform the project in its initial phase. We'll hear from a range of stakeholders about the evolving digital technology product landscape, some of the key product safety issues and health issues with such products, and related product policy initiatives, tools to identify and assess the risks, concrete case studies, and finally, an outlook on the future. The workshop outcomes, along with a range of other inputs, will inform a final report offering recommendations and best practices to be finalised late next year. Significantly, the interim findings of the project will be presented at a high-level meeting of OECD ministers on consumer policy in October this year. So without further ado, let's now turn to the first session of this workshop, which aims to set the scene for the following more focused discussions later on today. Consumer and business community representatives will provide us their perspective on the changing digital technology consumer product landscape and the broader implications for product safety regimes. To introduce you, our first speakers for the first session today are Noza Bujema, who is the Digital Trust Officer for Decathlon, Finn Lutzow-Holm Myrstad, Director of Digital Policy for the Norwegian Consumer Council, and John McNulty, Director of Product Safety and Compliance Engineering for Hardware at Google. Unfortunately, the representative from Samsung indicated previously in the agenda was ultimately not able to join us today, but I'm confident that the great speakers we have here will be more than able to provide us with an excellent kickoff. So I'm first going to invite each panelist to provide a presentation of about 8 minutes before turning to questions from you, the audience. You will have an opportunity to pose your questions through Zoom's Q&A throughout the session. So let me first now turn to our first speaker, Finn, who will provide us with a consumer perspective on the emerging consumer product landscape, with a particular view on products incorporating digital technologies. Finn, you have the floor.
Thank you. Thank you so much for inviting me and inviting a consumer representative. I hope that's also valuable to all of you. I'm not an expert in everything consumer related, but I'll do my best from the practical point of view. So I work today at the Norwegian Consumer Council, where I've worked for more than a decade investigating digital services. And what we've tried to do is to assess new emerging risks always. So that's everything from cybersecurity to dark patterns, deceptive design, to artificial intelligence. So I'll try to sort of just draw your attention to a few of the issues that we see emerging. And of course, we do hope that the product safety frameworks will be able to take up some of these risks either now or in the future. And we really hope to work with you to achieve this, because I think from a consumer's point of view, they just expect these things to work. And I do think that the product safety framework is can be a very powerful tool to achieve this. So my journey in this started really 2016 when we started looking at connected toys. And for those of you who've been working in this field for a while might remember the internet connected doll Kayla. This was a doll sold to children all over the world. It had internet connection and voice recognition technology. But what we discovered through quite basic testing was that this was a very hackable, very easy to hack device, in addition to voice data being transmitted to third parties and used for advertising. But this basically made the product unsafe. It meant that physical persons could get access to children's devices to either lure them out of the house or to, in other ways, influence them. And we've seen similar vulnerabilities in so many consumer devices that either have poor security or otherwise have flaws. And back then, we did file legal complaints to both the product safety authorities, to data protection authorities, the consumer protection authorities. And to our dismay, it really didn't fit into any framework. I'm not pointing any fingers here. I'm just stating that this is what happened. And in the end, Kayla was banned in Germany using legal frameworks dating back to the Stasi regime to prevent spying. But clearly, this was a product that, from a consumer perspective, was unsafe. So I'm glad to see there are initiatives now to embed better cybersecurity into products. But I definitely think that this is also a product safety issue. So I'll go through some of the points that I've noted, and I'm sure there are also other issues that other speakers will bring up, and I'm looking forward to the conversation. So one of the trends that we see now with digital services is that the rush to get to market makes consumers into guinea pigs. in practice. Products are often launched without being finished, without proper product safety testing, without proper risk management controls. And as a result, consumers are often left with products that are faulty, that stop working, or that in different ways are unsafe. And I think there's a bigger and bigger agreement now that we have to look at product safety in a wider lens. Of course, we don't want our VR headsets to catch fire while on our heads. So, the more traditional approach to product safety is still very important, but we need to widen our scope. I think I mentioned the Kayla story as an opening, but I could also draw your attention to other smart products which lack cybersecurity, and how this can be used to also impact physical security, but also, of course, mental safety and mental health. But just imagine, so I live in Norway, which is a very cold country parts of the year, and we rely on electricity to heat our homes mainly. So now we have a lot of smart products that you can buy from anywhere with smart thermometers. So you can adjust the heat in your house so you don't get cold or even freeze to death. We have seen lots of examples now of smart meters being hacked and malicious actors turning down the heat in the middle of the winter in housing complexes, for example. This creates, of course, a physical challenge or even danger for those people who might freeze to death. But also you can turn it around and see how connected products can impact our physical infrastructure. With the same attack surface, you could also imagine a malicious actor hacking these smart meters and turning up the heat in 50,000 homes in one geographic area, basically bringing the electric grid to a standstill and breaking the electric grid. So these are how cheap consumer goods also become a threat to critical infrastructure. And this is something we do need to, this is also things we need to have in our approach to product safety when it comes to these products. But look at it as a part of a chain, and a chain is never stronger than its weakest link. So that is a very important message from me. Also, the insecure devices can be used in, for example, massive hacker botnet attacks, where those devices are used inadvertently to attack other actors, such as websites or critical infrastructures. So the cybersecurity element is really important. Another element that's often overlooked is how digital tools now can be used for surveillance or stalking or social control. We see now with increased worry that companies sell products, for example, with location tracking. The purpose could be to track your luggage when in transit. But we see, for example, that AirTags from Apple's were launched without appropriate safety measures to protect from stalking, physical stalking, or how other products are used to socially control other individuals, whether that is an abusive ex-partner or a guardian socially controlling a child. So products are launched without having appropriate safety measures in place to prevent these negative horrible externalities. We also see how consumer products are increasing the ability to do commercial surveillance. And of course, this is connects to data protection, but we see also how data collected from smart devices can be misused also in other types of attacks that can be very harmful, both at an individual level or at the societal level, and also with relation to data leaks and harms related to psychological impacts if a system is breached. For example, imagine a baby call being breached. The data can be misused, but also the physical challenges that prevents in the environment of the user. And with artificial intelligence now, we've done extensive research into generative AI, and we see with worry that these systems are now being embedded without appropriate safeguards into smart products. Generative AI systems are generally quite opaque. They lack transparency and accountability, and they're full of mistakes. And this is also where we could draw a parallel to psychological harm or physical harm in the real world, where a user is using a physical device. It could be a robot, where generative AI is the interface that responds to the user's queries, for example. And that can have whether this is being used for mental health advice or whether it is used for other types of counseling for users or friendships, virtual friendships, where you create dependencies. And these dependencies can then be exploited because it's a machine that does not take ethical considerations into account. So with AI, the verge of AI now being integrated to more and more of these systems, it will add complexity and also have lots of unintended consequences, which I think should be defined within the realm of also product safety. And then I would love to discuss this more in detail, how this can be done. I also want to just mention lastly the issue of dark patterns, which is or deceptive design, which can now be built into the services, whereas before we often would have a screen to look at when and sort of identify dark patterns. Now they can be embedded to the system and also impair people's judgment or negatively influence them, which then of course can have all these knock-on effects as well. So those were just some of my points that I think we can discuss further and how it potentially fits into current or future frameworks of product safety. Thank you very much.
Thanks very much, Finn. We'll now move on to John. John, I'm just thinking about your responsibilities in one of the largest tech companies in the world. So what's your perspective on the emerging product safety landscape?
Well, thank you, Will. First, I want to start by thanking the OECD for the opportunity to talk with my fellow panelists and to you for moderating this session. So Finn led us off and touched on some of the points that I'll talk about from a manufacturer's perspective. I do want to start with a disclaimer in that what I will be discussing is based on public information, and the views that I express are my own, not necessarily those of my employer. So in terms of product trends, I'll introduce you to the range of products that we produce within Google's consumer hardware division, and then go from there to some more explanation of how it varies from Internet of Things to machine learning to AI-based applications, and there's a range even within our current products, and then how we go about the risk assessments from there. So to start with, just to give you an idea of the breadth of the products that we produce, they're all smart devices. They're generally all connected. So smartphones, tablets, wired and wireless earbuds, watches, and then a range of smart home products. So Finn just talked about thermostats. We also produce smoke and carbon monoxide detectors, cameras, indoor and outdoor, Wi-Fi routers, and also door locks, smart door locks that have a camera on them as well. With the exception of some accessories like AC power adapters, cables, things like that. These are connected products, and they have a range of assistive features in them with a really strong emphasis on assistive that span IoT, where when we talk about Internet of Things, we're really talking about connected sensors that are using just conventional firmware. And an example of what you can do with Internet of Things is remote access to a camera. And so someone rings your doorbell, a notification goes to your smartphone. If you're in another part of the house and not within hearing of the doorbell, you can simply access the camera and you can see who's at the door. And so let's say it's a delivery, you can just tell the person delivering that thing to you, oh, please leave it at the door, I'll come get it. Moving on to machine learning, this is where computers are trained to identify certain features. If it's any kind of sensor output, but it could be something like, to Finn's example with thermostats, training the thermostat with sensors around your home to really optimize the comfort level inside your home while also improving the energy efficiency of your home itself. So that's kind of the intermediate thing that has been happening for a number of years. And then, 13, 14 months ago, we started the AI revolution, essentially, where now these systems are capable of learning and growing. And an example that we have of our own product is Bard, which is a contextual language model that is able to understand people across a range of accents and a range of languages, and then provide interpretation for them as a web search tool. It's really synthesizing a large amount of information in a very concise way so that users can make decisions based on that. When I talk about AI in our products, this is not general AI. That is, it's not a truly autonomous thing that we are creating, but rather very specifically targeted. So I'll walk you through a couple of examples. First, let's consider contextual language models. Google Translate has been out there for a long time. So basically, based on images, I could be going to Paris to visit with you all in person, and I could see a sign, and my French is very imperfect, and so I basically use my camera on my phone to look at that sign, and it will translate that for me into English. That was a very early implementation, and I think that's Google Translate's now available in over 130 different languages. The next steps are really, when let's say you're writing an email, and the contextual language model knows enough about writing patterns to say, when you start a sentence, how it starts suggesting how you may actually finish it, so you don't actually have to manually type the whole thing out. And it knows enough about your personal patterns to suggest those things for you. And then the latest implementation is really, with very minimal guidance, it will provide full composition for you. Like, prepare my resume for a certain type of job, and arrange the information to address those particular points of that job, or write my email for me to try and be as concise as possible. The second application is in computational photography and image recognition. This is where we've spent a lot of time and effort in terms of, can you sharpen an image? Can you manipulate it so that someone who just photobombed your image, who just stepped into it, you can remove them and then basically use the model to interpolate what the background would be without that person or that object in it. And then also to add animation based on the features that it sees around the person or the object of your photography. And then the last part, which was also touched upon by Finn, is generative AI, where you might be able to create an image in a certain style just by suggesting, show me me in a medieval outfit, and then boom, it'll create that image for me, or in the mode of a certain type of animation that can be generated. But it could also create poetry, could create prose. There are some notable examples of lawyers using it to construct arguments, sometimes not very accurately, and laughably so when they go into court. Just to emphasize to you, though, that the artificial intelligence is mainly implemented in the cloud. That is, it's using the computing resources of data centers. And the computing resources needed to, functionalize AI are very significant. So you really need to have these very substantial computing centers to drive this in the cloud, and then do all the computing there, and then deliver the answers down to your device itself. However, there are now lightweight AI models that can be implemented in hardware on the device itself. So you don't need that cloud connection anymore. It can do a lot of the basic AI functions on your device. So now let's move to basically, how does this change our approach to risk assessments and product safety? Again, to my last point, these constrained AI models are still primarily software only, and the hardware that is driving them is essentially limited to processors, and that's true either in the data centers or on your device itself. We're seeing chips come out now that are optimized for particular AI models, and so you'll see that as the primary hardware implementation, but they just don't generally have access to controlling other aspects of hardware in a given system. With that constraint, it's easier to establish guardrails, what the AI can and can't do. But to try and put it in the context of product safety, whether that chip is in a data center or it's on the device, AI-driven or AI-optimized chips are generally much more power intensive than more traditional applications. And that has impacts for energy efficiency in terms of how much power a data center needs to draw, or how much a chip draws doing a particular AI function on a smartphone. And it also has impact in terms of thermal performance. And so if I have an AI chip in my smartphone, I need to have much more aggressive thermal controls to keep the touch temperature at safe levels. Now let's think about risk assessments. As Finn pointed out, I think we're still very much in the infancy of AI, and how we think about it, what kind of frameworks we have, how do we evaluate it, how do we certify it for use. So given that, we really started to address this, how AI in our products would impact the users through user studies. We started with internal, what we call dog fooding, which is people within my company trying out the product itself. We extended that out to trusted testers, that is people that have a longstanding relationship with us in evaluating our products. And then we did a beta release of Bard to the general public in progressively larger and larger sets, that then people try this out, they identify, they provide us with customer satisfaction scores and feedback, which we would call bug reports, that allow us to continually optimize functions and identify if there is some negative outcome, there's some misinformation that comes back out of a search, to continuously improve the products. But in going through those user studies, we're basically identifying some of the concerns about mental or psychological effects. And a lot of this comes down to your typical consumer is used to using a computer or a smartphone to essentially take commands from you. Go to this website, open this spreadsheet, perform this calculation. And now you're confronted with it's talking to you and it has a point of view. And that can be really off-putting to people. And so we've heard that kind of feedback from user studies of like, this is very disconcerting to people. Imagine the scenario where an alien comes down to this planet, speaks your language, but looks different than you. Probably your first response is not to immediately say, hello, my name is John, how are you doing? And then go right into a conversation. You might run screaming into the wilderness, and then eventually some bold individual will come forward and talk to the alien. How does that change when the virtual image of that alien now looks just like you? And so I think for a lot of people, that's going to at least require some amount of break-in period before they become comfortable with the technology itself. And again, for all of us as people concerned about product safety, making sure that we've evaluated all potential use cases so there's no potential for harm there. But to my section, I would at least want to close with a more positive view of how AI could be used for product safety itself. We're already using contextual language models for customer support to improve triage accuracy. Someone calls in, and then do they have a quality issue? Do they have a reliability issue? Do they have a safety issue? The contextual language model, regardless of the language that's being used, can identify more clearly how that should be bucketed into those three complaint categories. And so we can get to a more accurate outcome for the consumer. We can also use analysis of user-provided images for fraud detection. That is, are they providing an image of an injury, a failed product, property damage that is in fact taken from the web 10 years ago, and they're basically claiming this as their own. So you can do that like through Google Images for reverse image lookup. And then I think for regulators, you can use AI to essentially scrape the web, look for, let's say we've recalled a certain product, and we want to make sure that online primary marketplaces, but also online secondary marketplaces are not continuing to sell that product onto the market. You can very quickly identify which sites are offering that for sale based on the date of the recall itself. So that opens up the potential of really highlighting the assistive aspects of AI to help the consumer and really generally improve the quality of life for all users. Thanks, and I'll hand it over to Noza.
Thanks, John. That's really fascinating. I mean, very, very interesting indeed. So as you say, we'll now hand over to our last speaker, Noza, before we have a Q&A session. Noza, you're a distinguished AI expert, and you've worked extensively on trustworthy AI and AI risk and accountability. So what's needed for trustworthy AI in this rapidly evolving environment? And what does that imply specifically for consumer product safety?
Sorry. Hi, everyone. Do you hear me?
Yes, we do. I can hear you.
Okay. I have some trouble to share my slides.
No, Noza, you're quite faint. Your sound is quite quiet, I think.
Okay, sorry, there is some technical issue to share my slides. Maybe can you hear me?
I can hear you. Yes, we're fine. I'm wondering if colleagues from OECD can share your slides if you're.
Will colleagues from OECD share the slides? Yes.
We'll bring up the slides.
There we go.
Okay, very good. Thank you. Okay, in fact, I am here. I have the perspective of product safety from digital products which are powered by AI services. And what I would like to, okay, it's really sorry, it's very difficult to, okay, next slide, please. It's a pity that I cannot share my slides. Okay. So, in fact, indeed, the perspective is from AI-powered digital product safety from the perspective of AI trust. But first, trustworthy AI, in fact, it has been developed quite a number of years now at the international level, meaning from the OECD, European Commission, but also at the UNESCO. And we, in fact, the international community agreed almost on the same, in fact, principles that we can see in the next slide, please. Meaning, I mean, the international community, it's all about these principles that you can see on the right-hand side: accountability, human dignity and agency, privacy, cybersecurity and data governance, technical robustness and safety, transparency, fairness, equity and inclusiveness, and sustainability. In fact, it is all about human, physical integrity, but also mental safety and integrity. So trustworthy AI, it is all about these aspects, really to protect, in fact, not only human rights, but also the physical integrity. Meaning when we talk about human dignity, it is very important to have informed customer decision-making, to have customer self-determination. It is really important, and not, you know, having the, let's say, side effects of AI that we cannot master, and we do not know what are the side effects, by the way, if we are lacking transparency. Meaning there is a sort of asymmetry between service provider, AI service provider, and AI service consumer. So that's why it is so important to be, in fact, very careful about these dimensions. For example, someone can ask why technical robustness is there for trustworthy AI. I can give you one example. If we have an AI model which is not repeatable, neither reproducible, meaning that from similar starting point, I mean, starting, let's say, conditions for the algorithm and the model, we can land, if it's not repeatable, neither reproducible, we can land to different conclusion, different outcome of the algorithm. And this is by definition discrimination. Starting from the same point, we land with different outcome. And this is the basics, in fact, the baseline to ensure fairness, equity, and inclusiveness. So we need to ensure this technical robustness, because otherwise, if you do not have a robust enough, in fact, AI model, you will have unintended discrimination, meaning the people who build or who deploy this AI model without taking care about the technical robustness, they are deploying, in fact, a source of discrimination, which they do not, in fact, they do not have the intent to generate this harm. Okay, so that's why all this dimension, in fact, we can go into each of one, but it has been widely and internationally discussed. That's why, in fact, we, at the international level, we are more or less, in fact, agree on this, all of these property requirement to make AI trustworthy. So sustainability, if you see there, it is also responsibility with regards to the planet and to the environment, meaning we should be also very careful, not only about, you know, human rights, but also about our environment and about the planet, meaning we should not try to find solution, whatever the cost is, but we need to be very careful about model complexity reduction, but also data minimization. So that's why trustworthy AI, it's a set of responsibilities that we should have toward, in fact, people. And when I say people, meaning customer, teammates, collaborator, organization, society. So that's why it is really very important to take care and to make, you know, the AI responsible and trustworthy by design. It is very important to think about all these dimensions at the very early stages. Next slide, please. Yeah, so let me say a word here about the OECD approach. This is the catalog of tools and metrics for trustworthy AI, which is really the effort of a very wide and international community animated by OECD office and a group of experts. And this is available online in an open, you know, you can find it on OECD.ai website. So it is an effort really to, because when we say trustworthy AI, and you know, in the previous slide I was talking about requirements, properties of trustworthy AI, of responsibility, in fact, what does it mean? I mean, how we can be sure that it happens at the operational level. So that's why we need tools, metrics, and that's why I would like to highlight, in fact, that this link exists and this effort of the OECD with regards to trustworthy AI through multiple categories, technical approach, educational approach, but also procedure approach. And you can visit and see, you know, the richness of this, you know, catalog. Next slide, please. So here, what I would like to mention is that the work is not, you know, done. We have, as an international community, a lot of work still to be done, because today we have metrics which are mostly to measure AI performance and not really AI trust. And because also there is confusion between the two, you know, between AI performance and AI trust. Let me give a few examples here. For example, for the accuracy, like mean average precision or recall or force acceptance rate, you know, these are performance measures. It does not mean if you know, the AI model really have high level, figures for these performance measure, they are not necessarily transparent, they are not necessarily interpretable, they're not necessarily repeatable. Okay, so not necessarily trustworthy, and vice versa. Meaning we can have a model which is interpretable, transparent, and reproducible, and nevertheless, it maybe not high performance, maybe not high accuracy. So it is very important that we really spend more effort on these topics. If you can go to the next slide, please. Yes, in fact, really what I would like to highlight that it is not only a thought today when the OECD asked the international community to really contribute, etc., on the catalog of tools and about, you know, what are the metrics that I'm using for trustworthiness, etc. What we, after going into the catalog of tool, indeed, what we have observed and here measured that most of the metric are performance metric. So it's about 70% about performance. So that's why I said, I mean, more work needs to be done, meaning that to make trustworthy AI happen, we still, for the international community, is like a call, for contribution for work, still need to work on transparency and explainability, meaning interpretability, still need to have more work on repeatability and reproducibility, really to make trustworthy AI and responsible AI happen. Next slide, please. Yeah, in fact, I would like to say a word here about the EU AI Act, which is the European AI regulation, trying to put these principles that I start with about trustworthy AI as a, as a regulation. Of course, about the current, discussion about regulation versus innovation, regulation stop innovation, etc. So what I can say here, next slide, please, is that, in fact, while unleashing the power of AI, it is very important to develop in the same time the safeguards required by, in fact, the regulation is mainly to have these trustworthiness properties and requirements happen. At the end of the day, it makes us innovate on how to keep the trust between our customer, teammates, and more generally users. And this is for companies. In fact, it is profitable for business. So it's not only for compliance, but it's also profitable for business. So to me, we should not oppose regulation and innovation. Next slide, please. Yes. So at Decathlon, for example, indeed, you mentioned generative AI. It is very important that we also, and we are currently developing such, innovation program, which is responsible by design for retail profitability at Decathlon in my company, where we can, through feedback mechanism, provide human control and agency. But also, since we build ourselves these models, in fact, we have, the ability to provide transparency and interpretability. I'm not talking about explainability, okay, which is different notion. So we are able to provide the dimensions of the decision why this product has been recommended, for example, when the customer is asking or need, to know. And also, so really we are working on this, bandwidth with our customer, but also privacy enhancing. Why? Because we don't need necessarily to know who is in front, in fact, of our website or of our apps, because we are using contextual information instead of personal information. And we are very keen to have a, very optimized energy consumption models. And this is to say that responsible Gen AI, it is very important that we have an international movement and really, cross industries, that is reliable, repeatable, but also desirable and helpful through this human and control agency. Next slide, please. I think, yeah. Thank you very much, and happy to answer your question. Thank you.
Thank you, Noja. That was so interesting. As a regulator, I'm very interested in how we think about regulating in this space, and it's quite challenging, to say the least. I think you've set out some very interesting elements there, particularly thinking about tools and guidelines and codes. I'm very interested in how we take those kind of things forward. We now at the point where we can open the floor to questions and answers. But I might just start with one quick question. I'm gonna aim this at all three panelists. Just for brief answers, really. So we've heard a lot about rapidly changing technological progress and risks and opportunities. And I don't think we put enough emphasis on the opportunities. We're always a bit scared about new things and, you know, the Wild West, as they call it. But would you say that the consumers today are overall more or less protected from unsafe products than they were, say, 20 years ago? Who wants to go at that one?
I can jump in very quickly. I would say sadly less, and it's maybe I'm colored by my job, but with the influx of obviously there are better legal standards on certain areas, clearly, but I think it's quite sad that we don't have proper safeguards on cybersecurity, that it's taken this long to get basic cybersecurity standards in place. I wish that we could have recalls for the lack of cybersecurity. We don't have that, to my knowledge, and with obviously the global aspects of trade, and of course with how easy it is now to put up an online shop and do drop shipping and all these other things, makes that the regulatory protections that we might have in certain regions are being undermined by the fact that we don't have the same protections all over the world. And I know it's utopian to think we'll achieve a global standard on everything, but I do wish we had swifter enforcement on the whole, so that it doesn't pay to basically break the ethical standards and the standards that we do have and consumer expectations. So I would urge all authorities really to use, to the extent possible, use the existing rules you have to enforce, to sort of live up to the consumer expectations that products are supposed to be safe. Because I do think it's a challenge with the quick product to market that we're in now, and the ability to get away with quite a lot of bad practices, to be honest. So I would say sadly, and also our surveys show this, you know, that the consumers are lacking trust. And I think the NOSA's points there, you know, there's no opposition between innovation and regulation here. We should really see that regulation builds trust, and it builds innovation within safe boundaries. So so I don't mean to be too dark, negative here, but I do think we also need to look at reality in the eyes, because there clearly are lots of benefits, right? If we do this right, there are obviously lots of benefits for people who want, let's say, elderly who want to live home longer with safe assistant products, you name it. There are so many opportunities here, but they can be broken by the fact that we don't manage to manage the risks. Thank you. Sorry.
Thanks, Finn. I'm going to
I'd be willing to jump in, Will.
Yeah, go for it, John.
Okay, so I'll provide an opposing view. Not necessarily, I mean, I appreciate what Finn just said about cybersecurity. If we think about just in the conventional realm of product recalls and ensuring that you're able to get unsafe products off the market, I would say that we're more safe than we were 20 years ago with respect to certain products. If you were talking about a baby crib, you have to resort to, you know, you may not know, the manufacturer may not know where the consumer is. They'll have to resort to print advertisements, TV advertisements, other forms of information to try and get that message out to the user of that product. If it's a smart device, I can send the manufacturer can send an on-device notification to the user, contact them directly because we have their contact information on file. We can also, if it is simply software or firmware that's actually causing the unsafe situation, we can provide an over-the-air update and then push that to all devices that are active worldwide. And so we just have a much easier way to interface directly with the consumer and understand their perspective and then provide them with a remedy.
Thanks, John. Nosa, very quickly, are we safer now or were we safer 20 years ago?
We cannot wait 20 years, okay? so definitely we have elements, in fact, for being, you know, having safe AI, but definitely we cannot have 100% of safety today, but I think it is manageable within 1 or 2 years. So to elevate the readiness of multiple stakeholders, because you know, metrics and the risk assessment and risk mitigation even though there are quite a number of AI risk management frameworks. I can mention the NIST, for example, the IEEE, I mean, the ISO, etc. There is a lot of, initiative to make the AI risk to develop standards, but in fact we need to go more in depth and more in accurate and interoperable metrics, which is happening in fact today, because the topic is not so easy from the technical perspective. So that's why, I mean, today quite a number of people try to go through kind of checklists to say, yes, we are safe, yes, we are repeatable, yes, we are trustworthy. But the issue is that today it could be only declarative trust, okay? What we need is measurable trust. So the measurability for the trust and for the compliance, by the way, it will take some time, but definitely we are on the right track if really we move and we spend effort and investment to make this principle happen. Not, again, I really repeat it again and again, not only for compliance, legal compliance, but also for the economic profitability. It is really win-win situation. If we it's important, when you have, for example, an AI prediction for product availability, having trustworthy outcome is also useful for companies. Okay, so it's it is beneficial for everyone. So that's why, to me, it should be really okay. So it is not in 20 years, definitely, but yeah, to me the readiness probably will take 1 or 2 years.
Thanks very much, Noza. I'm really sorry, but we've come to the end of this session. There are a lot of questions appearing in the chat and in the Q&A bar, and I would ask our panelists if they could take time just to provide some answers to those. I think you have the ability to type your answer in there. I'm sorry that we haven't been able to actually make time for those for our responses to those. But I think it does show that we're going to have quite an interesting set of questions and answer sessions going forward today in this workshop. So I'm really quite energized by that. I think it's going to be great. I'm just going to make some closing remarks now before I hand over to the next session, which will start in 2 minutes' time. So we've reached the end of this session. As I say, I'd like to thank everybody for posting those great questions, and also the panelists for their really thought-provoking presentations. There is so much to talk about here. My takeaway from this discussion is clearly that as regulators, and I'm a regulator, we really are at a turning point. We've got to think very, very carefully about how we proceed. We've got to collaborate much more, I think, probably with industry and academia, and we've got to take stock. And as Noza set out in her presentation, there's a whole range of codes and regulations and guidelines and tools that we need to develop. So we've got to take stock of the changing consumer digital product landscape, thinking about risk, particularly those related to mental health and new types of products. The safety is increasingly relying on intangible components, and those intangible components change regularly. So we've got to think about how we are agile in our regulation. We also need to think to reassess whether our approach to product safety risks, the traditional, does it hurt me, does it burn me, does it cut me, does it poison me, those kind of things, is still fit for purpose. So I'm very much looking forward to the following sessions, which should help us with those important tasks. And I'm now going to hand over to Andras Sigmund, who is moderating the next session. Andras, over to you.
Thank you very much, Will, and thank you very much also for giving me the possibility to moderate the next session. Indeed, we will continue our discussions, and we will now focus very much in our session on what are actually the new emerging risks which are associated with digital and new technology products. So we will have quite an interesting discussion on this, and we will also be able to explain you some policy initiatives which are already looking at these risks. But before going into the details, let me first introduce you to our esteemed panelists, and I would also like to ask them to turn on their cameras so you will be able to see who they are. So first we have Martin Allen from the UK, Technical Director, Electrical Safety First. Second, we have also Birgitta Dresp-Langley, Director of Research from the French National Center of Scientific Research. Then we have Tatiana Evas. She is a colleague from DG Connect of the European Commission, and she is a legal and policy officer working on the AI Act. And finally, but not least, of course, we have Jesse Love from the US, Technical Consultant Specialist from Bureau Veritas Consumer Product Services. So in our panel, just to give you a couple words on how we are organizing the discussions, we will follow very much the model which you saw in the previous panel. So we will have the presentation from all our four panelists, and then afterwards we will continue with the question and answer session. The only difference compared to the previous panel is that I was asked by the organizers to speak a bit in the context setting about the EU General Product Safety Regulation, which of course I'm very happy to do so. So just to set you the scene, many of you probably are aware that in the EU, we recently adopted a new General Product Safety Regulation, which is by type a very wide coverage type of safety net legislation. What do we mean by safety net in this regard? Is that our aim with this regulation is to fill all the gaps which are currently happening on product safety rules, with the aim to ensure that all products which are entering EU markets and which are ending up at the hand of EU consumers remain safe. The objective accordingly is really to protect the health of consumers, and we put a lot of emphasis in this regulation on the health being a very complex state of mind, not limiting to physical health, as Will already explained you, but also to look very much into mental health risks. And this is also the reason why we are defining products in a very wide and future-proof way. So we are basically covering all potential items, being interconnected or not, which is to be used or likely to be used by consumers. So this means that in the General Product Safety Regulation, we are covering furniture, we are covering fashion items, but we also indeed cover software. And this is really a reason why our main objective and the main requirement from producers and developers is to only put safe products on the market. And we put a lot of emphasis on these new technology items by looking at connectivity, for example, as aspect of determining the safety of the product, or self-learning capabilities, or cybersecurity risks. So this is something which we adopted last May as a regulatory framework, and this will apply from 13 December this year. So we are now very actively reaching out to all stakeholders, authorities, businesses, to make sure that they are aware of the new rules and to make sure that they are ready to apply. And just to add one more point, which is quite add to the complexity, and I'm sure that our panelists will talk about this today, is that when we look at products, now it's really different to the concept of what we looked at products 20 years ago. Now, for example, with digital products and digital services, the complexity is really high, and there is no clear division anymore on what we could consider service and product. That's why we have to make sure that the rules are applied in a way that they ensure safety, and this is really our clear objective. So this would be just to give you a bit of context on the European work in general product safety. And by this, I would also like to invite the first panelist, Tatiana, to give an overview of another piece of the regulatory framework on the Artificial Intelligence Act in Europe, which is just at the last steps of the making. So Tatiana, the floor is yours.
Thank you very much for this nice introduction. And my presentation will build very much on the closing presentation of Nosha, which she finished with AI Act. So just give me a second to start my PowerPoint. Okay, second. So I hope now you can see, or in a second you will see the presentation. Yeah. So thank you for this very nice presentation, and it's a good opportunity to go a bit deeper in the regulatory setup. So in particular, Artificial Intelligence Act, which will indeed, and thanks to Nosha for bringing this background, we'll look at the aims to address exactly the risks which are specific to artificial intelligence, which bring new challenges to our safety overall acquis, so overall safety legislation, but also the supervision and all related issues to safety. But before I go into details of AI Act, maybe just a few words to explain what are the main reasons why European Commission decided to go beyond just code and principles and really propose a legally binding regulation. As you know, so there are a lot of now initiatives going in order to kind of speak to the ethical or trustworthy AI, but really we felt at the European Union that we really need to move beyond those discussions and really look at the legislation. And that's why in 2021, European Commission has made a proposal to set up horizontal legislation which would look at the risks related to artificial intelligence. And of course, before coming up with this legislation, there was a lot of discussions, do we really need it? Of course, we already have, in particular in European Union, we have very strong product safety legislation framework, which cover different products. We also have a very strong consumer protection legislation. We have anti-discrimination legislation. So the question was, do we really need something on top of this? And our answer was yes. And the reason is because artificial intelligence technologies, they bring new dimension. So, and particularly the characteristics of the AI, which relate to complexity, opacity, and predictability, autonomy, and data-drivenness, make the application, enforcement, and exercise of certain existing legislation and certain rights are challenging. So the idea then was that in order to actually really have something measurable and clear in order to facilitate trust among citizens to trust these technologies, we really need a horizontal legislation which will clearly set up the rules. And the type of risk which we wanted to address specifically through AI legislation is the risks related to health, safety, and fundamental rights. And here it's very important because, of course, traditional product safety legislation mostly focus on health and safety. And of course, I know that there are different broad interpretations of what safety, for example, means. But we wanted to be very explicit. So AI Act really specifically refers to health, safety, and fundamental rights as type of risks which we want to address in order to enable trust and address exactly these characteristics of AI systems related to complexity, opacity, and so on. So how did we practically go about it? So in 2021, we made a proposal in this legal act, and this is a very, very quick review of the main points of AI Act, really to explain why, in addition to already existing safety product legislation, which we have in European Union, and to which Artificial Intelligence Act will contribute, and in addition to general product safety legislation, which was just introduced, the AI Act will be like a specific safety additional tool which will complement. So it will not replace, but will complement already existing legislation with specifically looking at the risks related to use of AI technologies. So what are the key elements of Artificial Intelligence Act? So how do we go about meeting this regulatory challenge to providing more trustworthy AI in the European Union? First of all, the AI Act will defines what AI system is, and we adopt the broad definitions. So AI system covers both the products which embedded AI, but also like pure services like recruitment software or recommender system. So we adopted a very broad definition of what AI system is. Still, it is AI specific, so it doesn't cover every software system, and it doesn't cover every automated decision-making system. So it's still a system which is built with one of the AI techniques, for example, machine learning or knowledge and knowledge-based techniques. So we define in the Act what AI system is. Secondly, what is, I think, very crucial for understanding that AI Act does not regulate technology, AI technology per se. So we don't say this AI technology is good and this AI technology is bad, but rather we regulate or attempt to regulate the uses of AI technologies. That's why in the next slide, I will show you these risk categories. So we don't look at the bad to good technology, we look how this technology can be used in specific cause. So for example, if AI is a safety component of medical device, it's a high risk and requires certain rules. But while if AI system is used in entertainment software to recommend which song you should listen in the evening, maybe it's not high risk. That also takes me to the point that, of course, AI Act introduces risk-based approach, which means the requirements are commensurate to the risk that a certain use of AI technology can bring. Third point is that AI legislation is horizontal, so it will apply across the sectors which are within the scope of AI regulation, which is quite broad. And for us, it was very important because we believe that risks which AI systems, use of AI systems can trigger to health, safety, and fundamental rights were really horizontal. So in that sense, whether you embed AI in a toy or machine or your smart watch, which gives you safety, health advice, you know, it's not important because risk could be very similar. So we wanted to have the minimum safety level protection to the risks of AI system across different policy areas. So in order to build on this risk-based approach, we have 4 categories of risk, and I will speak briefly about it. And then the overall setup of AI Act really follows the product safety legislation, which means pre-market authorization by either through self-assessment or through notified body, and of course, post-market supervision from market surveillance authorities. Important that AI Act does not bring a new categorization what products are risky. So we built on the existing sectoral legislation. So for example, if under machinery regulation, the machinery is a certain machine is considered to be subject to third-party conformity assessment, for us, that's triggering mechanism which will put that in the high-risk category. But said that, it's a horizontal legislation, which very much complements the existing sectoral legislation. It also means that in practice, it will also build on a lot of existing structures. So for example, it will integrate in a lot of already existing procedures, like for example, if the third-party conformity assessment is required under the existing product safety legislation for a certain product, the same conformity assessment procedure would apply. However, this conformity assessment procedure would have to be enhanced with checks related to AI-specific risks. And just takes me to the next slide, which...
sorry,
yeah?
Could I ask you to put it to presenter mode because some of the participants said they cannot see?
Okay, sorry. So it takes me to the, maybe just display the last slide so people can see it who didn't see it. So it makes me to the next point, which I wanted to raise, the 4 categories of risks. Like I said, AI Act does not regulate, first of all, AI technologies, but use cases. And secondly, these use cases are regulated in a risk-based manner. So it means the higher the risk we see to health, safety, and fundamental rights, the higher the more obligations the providers would have to comply with before the product could be put in the market. So AI Act rules come to the product before the product is put on the market. And this is the 4 famous categories, which some of you might be familiar. So under AI Act, certain practices will be prohibited. And I think it's interesting or important to note that in context of this specific discussion and this session, that subliminal techniques which exploit vulnerabilities of certain groups will be unacceptable. So AI systems use cases which lead to that would be prohibited. Then we have, and it's the whole bulk of regulation that will focus on high risk AI systems. And then we have another category will relate to transparency risk. That's particular for chatbots, which would just make people to be aware that we are communicating with AI system. But then the rest of the use cases, which we consider as minimal or no risk, will be not subject to any legislation. And to end my presentation, just a short overview of what AI specific components or AI system within the whole product would need to comply with. And you see here the 10 important elements which the system would comply. And I think that's also our way in European Union to go through just codes and checklists to really go to specific regulatory compliance push, which I agree with Nosha will only facilitate innovation rather than kill. And here you see exactly our translation on how to address risks coming from opacity complexity by providing, for example, as you see, more information, transparency, measures related to trustworthiness, which the AI-enabled products will be subject to. And with this, I'm ending my presentation and I'm looking forward for the questions and comments later. Thank you.
Thank you very much, Tatiana. It was really a very interesting and very complex presentation, and I'm sure that everyone is looking for the moment to finally see the text. But by this, now I would like to move to Jesse, and Jesse will give us a bit of overview about different issues which might arise in the context of autonomous products, such as robotics or human-machine interactions. So Jesse, the floor is yours. You are still muted, Jesse.
All right. Thank you very much. My name is Jesse Lowe. I'm from Bureau Veritas in Buffalo, New York. Today we're going to talk about navigating AI in product safety. So AI systems, particularly those involved in critical tasks like autonomous products, must function reliably and predictably. Malfunctions, software bugs, or errors in AI algorithms could potentially lead to physical harm to users or others in the vicinity. If AI-powered consumer products do not have appropriate safety measures in place, there is a risk of physical harm. For example, autonomous robots without proper collision detection or emergency shutdown mechanisms may collide with users or other objects, causing injury. Complex AI systems may require users to understand their limitations, operating procedures, and potential risks. Inadequate user instructions or poor user interface design may lead to incorrect use or misuse of the product, resulting in physical hazards. For example, smart home automation systems. AI-driven systems allow control over various devices and utilities. Insufficient user understanding of system interactions, programming, or device capability could result in unintended device activations, malfunctions, or safety hazards, such as improperly controlling heating or electrical systems. AI systems that rely on sensors or environmental inputs can be susceptible to interference. For instance, some home security systems, AI-powered security systems in smart homes, utilize various sensors, including motion detectors and cameras, to detect potential intrusions and threats. Environmental interference, such as poor lighting conditions, reflections, or obstructions, may affect the system's ability to accurately detect and respond to security incidents, potentially compromising the effectiveness of the system. Machine learning algorithms rely on quality training data. Insufficient or biased training data may affect the AI system's ability to recognize or respond appropriately to certain situations, potentially leading to physical harm or unsafe outcomes. For example, autonomous products. Lack of diverse and comprehensive training data may lead to limitations in recognizing and appropriately responding to various conditions, objects, or scenarios. This can increase the risk of accidents, incorrect decision-making, or failure to detect hazards accurately. AI-enabled consumer products connected to networks or the internet may be vulnerable to cyber attacks. If security measures are inadequate, malicious actors could gain unauthorized control over the product, potentially leading to physical hazards. For example, robots. Inadequate security measures in AI-powered robots can make them vulnerable to hacking, tampering, or malicious manipulation. This can result in physical hazards, such as the robot causing harm to users or the environment, or unauthorized access to sensitive areas. Next, we're going to talk about how AI and machine learning product safety differs from traditional approaches. AI-enabled consumer products often incorporate complex algorithms, machine learning models, or neural networks. This complexity can make it challenging to fully understand the system's behavior and potential risks. Traditional approaches typically rely on well-defined rules or known physical principles, where AI introduces a level of complexity that may require specialized expertise and novel safety assessment methods. Some AI systems, such as deep neural networks, can be challenging to interpret or explain their decision-making process due to their black box nature. Traditional approaches often rely on clear causality or transparent decision rules that can be more clearly understood and verified. AI systems can learn, adapt, and evolve based on new data and experiences. This dynamic nature poses challenges for traditional static safety assessments, as AI systems can exhibit unforeseen behaviors or performance changes over time. Continuous monitoring and evaluation are crucial to ensuring ongoing safety as AI systems evolve and interact with real-world scenarios. AI systems rely heavily on large amounts of data for training, inference, and decision-making. The quality, representativeness, and biases present in the training data can significantly impact the safety and fairness of AI-enabled consumer products. Traditional approaches may not have focused as extensively on data collection, labeling, and potential biases associated with training data. AI-enabled consumer products often involve direct interactions between humans and machines. Traditional approaches may have focused more on physical safety hazards, whereas AI introduces new considerations for human-computer interactions, user interface design, and ensuring that users understand how to interact safely with AI systems. Next, we're going to talk about insights, guides, and standards. So artificial intelligence, the CPSC report introduces AI and machine learning by presenting a safety evaluation framework for their use in consumer products. It is aligned with CPSC's goal of reducing injury risk and notes the increasing feasibility of AI machine learning applications due to advancements in technology. UL 3300 provides guidelines for evaluating robot safety by focusing on mobility, fire, shock risk, interaction, user types, and environments. It highlights the importance of safe human proximity in various settings. ISO IEC 30141 standardizes IoT architecture, offering a framework with common terminology and best practices, starting with key feature definitions and conceptual modeling, then followed by various architectural perspectives. The NIST AI Risk Management Framework provides guidance for incorporating trustworthiness into AI systems through their lifecycle. It is supported by tools like AI RMF Playbook and the Trustworthiness and Responsible AI Resource Center to promote global risk management practices. Continuing, the ASTM F3463 Committee provides AI requirements, definitions, and risk assessment guidelines. It serves as a starting point for risk evaluation, with labs like Bureau Veritas offering related testing services. Encourage anyone to join 3463 Committee and contribute to our safety guide. You don't have to be an expert, you just have to ask the right questions. In closing, AI-equipped products are generally safe. In instances of failure, though, the consequences can be catastrophic, which highlights the importance of adopting a proactive approach. Thank you.
Thank you very much, Jesse. This was really a fascinating presentation as well, and very interesting to see the issues and also some responses already in the standardization work. I would like now to give the floor to Birgitta, who is a scientific expert, and she has very extensive experience in neuroscience, psychology, and also in philosophy. And I would be really curious to hear from you, Birgitta, about the possible risks and harms related to new technologies such as virtual and augmented reality. So floor is yours, Birgitta. You are muted, Birgitta.
Yeah, thank you very much for inviting me today. I've got my sound on now. Thank you. So I was asked to say a few things about virtual reality today, which I'm pleased to do so. So virtual reality is promised or announced to be soon powered by generative artificial intelligence. So this is the future announced by several companies. And it promises to be a novel technology where Gen AI, in short, generative artificial intelligence, will be leveraged to craft novel 360-degree worlds that will sculpt entire new landscapes of the mind and transform abstract visions into concrete realities. This is the promise. And it's actually interesting to see because this promises to be the creation of novel worlds where the boundaries between fiction and facts will progressively vanish. Now, the point I'm going to talk about today is actually virtual reality good for the brain? What happens to our brain when we use a virtual reality, be it in a headset, which is something that's what we wear, or in an immersive cave, a fully immersive cave? These are rare. So it's mostly actually headsets we're talking about. So what happens to the human brain when it is exposed to virtual reality? Now, what happens at the level of perception, learning, and adaptation is behavior. But first of all, what happens is something more central, something more systemic. There is scientific evidence that has shown that some neurons in the brain start responding differently when an individual is exposed to a virtual reality environment. These cells are so-called place cells. They are situated in the hippocampus of the brain, which is a structure that governs spatial perception and perceptual reality in a way. So what we have to bear in mind is that the brain codes the three-dimensional real world in 2 dimensions, not in 3. We learn to infer three-dimensionality into the real world when we start to walk. When we start as small children to walk around to the real world, we anticipate three-dimensionality of objects by touching them, manipulating them, and by navigating interactively with the real world, and thereby we progressively construct 3D representations. And that then leads in the brain to the formation of specific neuronal circuits that are capable to actually code the 3D world as it is outside. Now, what happens when our brain is all of a sudden confronted with virtual reality? Well, first of all, at the perceptual level, there's something happening to our spatial perception, and that can be measured in behavior. We have published a study years ago with a doctoral student, and we were using image-guided precision tasks where the operator had to generate a few highly precise trajectories, object movement trajectories in the field, either with 2-dimensional image guidance or with a VR headset. Now, it turns out that the trajectories are less precise with virtual reality guidance and more precise with 2-dimensional image guidance, which was not surprising to us because we know that the brain actually codes 3D reality in 2 dimensions, so it makes sense. And then some of these differences were statistically significant. So this is one thing. Another thing that is difficult for human beings to anticipate and to apprehend in a virtual reality environment are relative distances. Relative distances between objects in the plane and in the recreated virtual 3D reality, and also time to contact estimates are very difficult to make. So if you use virtual reality in a work setting, let's say we have operators who have to perform highly precise tasks, then there is a risk that their precision will suffer from the virtual 3D reality presentation. So they probably will do better with a 2D image. Now then what happens at the level of our, I would say the more psychological level, if you wish, is that prolonged exposure to virtual reality has been shown to lead to a certain number of psychological effects in terms of an increased sense of presence in the virtual reality environment and a diminished sense of presence in the world as it really is. So this is interesting because it quite clearly shows that the fact that our brain is challenged by this novel environment, this novel three-dimensionality it is not used to, can lead to other phenomena, to other feelings and subjective experiences that have their consequences on human decision-making. And this will be directly impacted by generative artificial intelligence, because we're then dealing with increasingly fictive worlds that sort of create a huge gap between the reality as we may experience it in our everyday life, and the reality we get confronted by in these virtual reality environments. Now, an interesting phenomenon that has been observed in virtual reality is cyber sickness. Some individuals experience it, others don't. So there are a number of publications on that topic. It's interesting because it is probably a warning signal that our brain is sending us when we're in a virtual reality environment. The brain is sending us a signal saying there's not something quite right. What I see here is not the world as I learned to see it, well, I being the brain in this case. Sorry for putting an eye on the brain, but it's true, we perceive the world with our brain. The eyes are just a filter. We have to bear this in mind. So yeah, the brain gets signals, stimulus, influx that it is not used to, and then can send top-down signal in terms of cyber sickness. So people feel unwell. They might have a desire to vomit, and some people might even lose consciousness. It happens in rare cases, but it does happen. So another aspect of virtual reality, it might not be specific to the device itself, but to the way it is maybe commercialized and broadcast, I don't know, but it can lead to addiction, of course, especially in teenagers, like any other form of behavioral addiction, like, for example, video game addiction. And then we have a certain number of chain effects that enter into the equation, because at the beginning it's fun to be in these novel worlds, to experience these new realities, and then we go there more and more often, and then it becomes compulsory, and the spiral of an addictive brain response is triggered. So addiction is something that is created in the brain. It is not something that people have a choice. You know, it's not psychological. It's not only psychological. There's a psychological dimension to addiction, but it's first of all happening in the brain. So then there is a pathological adaptation to this novel world that then produces a compulsion to use virtual reality or video gaming or whatever it is more and more frequently. And then we have problems of mental health that are related to a perturbance of the control mechanisms the brain uses to control for anxiety, stress, and that can then, especially in teenagers, there's a serious trend out there where they develop depression, suicidal ideation, and things like that. So to finish on these potentially negative consequences of virtual reality for the human brain, I would like to use a few keywords that one can take home. So we must think in terms of altered spatial perception, altered perception of relative distances, inaccurate motion trajectory and movement trajectory planning in the virtual reality world, and problems of adaptation. And also what we have to think about is when we use virtual reality for long hours, then take off the headset, take our car and try to drive home, our perceptual system has then to readjust to the real world as it is. So there is a complex chain effect there. First adaptation to the virtual reality, then readaptation to the real world. So we do not know at all what the consequences of that could be. So there's a big question mark. So the perceptual level, then we have the decision-making level, of course, because perception is a condition for all the decisions we make in real life. Decision-making depends a lot on our perception. And then all the other psychological side effects virtual reality can have when it becomes a device that is used as a drug for recreational purpose first, but then with a chain effect that can become or turn into an addictive response triggered by pathological, what we call in science, pathological brain adaptation to the cue stimulus that triggers the addiction. So I will stop here. Thank you very much for having me today. I'm a bit of an outsider here, so I hope you enjoyed the presentation, and I'm ready for your questions.
Thank you very much, Birgitta. I think it was really an eye-opener presentation for all of us, really, about the altered perception. So I'm also looking forward for the discussions afterwards. But now this brings us to Martin, and I'm very curious to hear from Martin also what we can do to ensure that the consumers remain safe, but at the same time they are still able to enjoy the benefits offered by these new technology products, such as, for example, the virtual reality. So Martin, the floor is yours.
Thank you, and hello everybody. Delighted to be part of this panel. Some great discussions already, and looking forward to the conversations later on the day, and certainly the Q&A that we have here. It's good also to get the consumer voice. You know, as a consumer, we expect our products to be safe, secure, and increasingly sustainable, which is quite a big challenge really in today's modern world. Ensuring the safe design of digital technology products before they're placed on the market or made available on the market is really front line to ensuring consumer protection. You know, close second is to ensure safety is considered throughout the product life cycle, as design is often upgraded during that life cycle, and there have been many consequential effects from software changes and component changes. Now, those 2 points relate to the normal operation of a product and to address the product safety issues as a result of design flaws or failures in the product and its constituent parts or associated parts. But of course, for digital products, it's also vital to ensure that product security is factored in to address the abnormal operation due to cyber attacks. So product resilience must also be considered, and again, at the design stage and throughout the life cycle. I think it's probably worth sort of stepping back and just thinking about what the constituent parts of a digital product are. And I'll change my background a bit. And I've stolen this diagram from a colleague of mine, Peter Eisinger, who's from the National Consumer Federation. He's probably in the virtual audience somewhere. I think it's a great way of just depicting on what we're sort of talking about. And you can see, hopefully, that for all digital products and products in general, to be fair, you have a number of sensors. And those sensors are looking at the physical conditions in the environment or condition of users. That could be temperature, energy, position, a whole raft of things that are being sensed. From those sensors, then you would have a number of actuators, and they would allow the digital signals to activate or vary the delivery of forces or powers to machines, power to heating or lighting systems. They may be used to provide instructions or information to the users. To make that work, you need a degree of logic, and that logic is realized through software, including artificial intelligence, of course. And you may or may not have an interface addressed for the human. You know, if you've got a human interface, that may be using buttons or levers, you know, so you've got line of sight, or you might even have remote access. That human interface might also be delivered through displays, through speakers. It might have also additional security to restrict access to those products. But if you've got automated control, of course, without human involvement, then that top part disappears altogether. So when we consider that all in the rounds, and you look at the standards that exist for particular products, there are about 4,500 specific product standards covering the products that we know in the marketplace. They're generally not really fit for purpose for digital technology products. So we worked with the National Consumer Federation to develop a set of safe design principles that I'm sure, you know, both NCF and ourselves will be happy to share with the project going forward. We don't really have enough time to go through in detail, but I'll cover some of the headlines of those principles just now before we get into the broader discussion. So thinking back on the diagram I showed before, in terms of sensing, safe sensing, principle 1, think that if you're relying on safety critical functions and operation, that shouldn't be dependent on one sensor. You need to have redundancy built in. The sensors themselves need to be capable of sensing that hazardous condition, you know, from reasonable foreseeable use. The sensor themselves needs to be compatible with the actuator and the control system, and also interoperability with many different sensors. They shouldn't compete and create a hazardous condition. And the next principle is around consumer control, to make sure that if you're talking about manual control, then the consumer must always have an overriding capability. Third parties shouldn't be able to override without the person at the front end is allowing that to happen. An exception to that may be where there's a product recall and it makes sense to intervene on the consumer's behalf to deactivate an item. The next principle around safe automation actuation, then the actuators themselves need to be capable of reacting to the hazardous condition so that the actuators also don't injure the person and greater than the risk that it was trying to eliminate in the first place. Another principle is around safe remote control. Remote control should only be available when it's possible and even enabled, and also that remote control shouldn't move outside the safe parameters of the consumer themselves. So, for example, the temperatures shouldn't be permitted to fall below temperature X or above temperature Y, for example. And also there needs to be consideration of consumer awareness of the risks. For example, the use of a smart product used with, or non-smart products used with a smart interface. So there are many smart sockets on the marketplace that you can switch on and off remotely. But if you've got a non-smart heater plugged into that, then that might not be great to switch that on remotely if it's next to some combustible material, for example, or it's fallen over or been knocked over by a pet, for example. Another principle is around designing for real consumer abilities and their behaviours, including their vulnerabilities. We really do need to factor in the consumer in terms of what they're capable of and not capable of. And any instruction that's provided the product needs to be intuitive and needs to be simple and easy to understand. Of course, it was mentioned, I think, in Will's opening remarks about the need to consider when we lose the functionality in terms of the Wi-Fi, or if there's a software being updated during normal use. Where that is indeed the case, then the product must revert to a default safe mode. And also, when functionality returns, of course, then we must consider the effects of that product just starting to operate again, so it doesn't lead to an unsafe situation. In that situation, of course, if that was possible, there must be authorization or oversight by the end user. We need also to consider the interfaces. I think it was touched in previous remarks about the interfaces need to be really clear, so that clear instructions to the consumer and they're alerted to when there's remote operation or when there's an unsafe condition. Security needs to be built in, as I mentioned, up front. And then last but not least, because I'm conscious of time, is around the need for installation. So there's a principle around installation of the product that ideally it should be designed so the consumer can simply plug it in and the instructions walk you through to make sure they can operate safely. But if that isn't indeed possible, then it must be obvious and clear that you need to get a competent person in to make sure the product is installed in accordance with the manufacturer's instructions. Like previous comments, I'd like to end on a positive and say that I firmly believe that the safety benefits of digital technology, including IoT and AI, outweigh the risks, which is why this work is really so important to get it right so we don't lose confidence in the marketplace. Thank you.
Thank you very much, Martin, and thank you also for finishing in such a positive note. So this brings us to the end of the presentations, but we have close to 10 minutes now still for the Q&A. So if you would allow, I would like to pose one question for each of our esteemed panelists. Maybe I could start with Birgitta. Birgitta, I would be very curious to know if, from the scientific point of view, if you could already identify a clear line between what can be considered physical and what can be considered more mental health harm. And this I'm also in the context of this altered perception you were mentioning at the end.
Yeah, it is a question that is kind of problematic because you suppose that you can separate physical health and mental health. This cannot be done because there is no health without mental health. And if let's say if we have future generations of teenagers addicted to virtual reality, let's just be really extreme and caricature this, then these will not be kids that will be happy or healthy in any other way, because we know that addiction to digital technology leads to other symptoms such as eating disorders, sleep disorders, and these then have severe physiological consequences and so on. So yeah, I think this is a question that as a scientist I can only answer in one way. There is no health without mental health. So if we can ensure that these novel technologies and this artificial intelligence that's coming towards us is going to make us happy, thriving on all fronts, economically, physiologically, mentally, then that's fine. But if it becomes a more and more stressful environment because the AI takes over some of our control and our capability to say we are in charge, we are at the origin of the destiny of our humanity, and so on. When we have no longer any control or have the feeling of loss of control, simply as Seligman would put it, we become a new generation of people with acquired helplessness syndrome. We do not no longer know where we are going with this. And so mental health is a priority. And you cannot say what's physiological, what's mental. Mental health problems originate in the brain. They always do. Any scientist will tell you that. And,
Thank you very much.
So maybe
it's a
this
very
is not a
strong
satisfactory
conclusion,
answer, but
no, absolutely, it is a very conclusive and very strong conclusive answer. So
Okay,
thanks a lot, Birgitta. Now, if I can go back to Martin, because you were mentioning in your presentation a lot about cybersecurity measures, especially in the design phase and also throughout lifespan. Can you a bit explain what, as an example, what the UK is doing in this regard now?
Yes, sure. I mean, the UK is on the cusp of introducing the product security and telecommunications infrastructure regime. And what that does is it's implementing 3 of the 13 requirements that are included in the ETSI 645 standard. So those 3 requirements are no default passwords, somewhere to report vulnerabilities, and having an end date for providing software updates. So it's quite light touch in terms of the 13 requirements that are included in the ETSI standard. That comes into force on the 29th of April this year, so less than 100 days now, that manufacturers and retailers need to get themselves in the position of compliance. The interesting part for this legislation is that it actually captures products that are made available on the market. So there are some products that were, well, still available, but they were manufactured even before discussions on this legislation were actually initiated. So we're in danger of having some products that will fall out of compliance with the cybersecurity measures, but then that would seem crazy that they would have to go to a landfill or to be recycled, because that's at odds with another government policy to do sustainability and reducing electronic waste. So, you know, it's really, there is a conflict, and some manufacturers and retailers are up in arms, and they're trying to, you know, find out what they have to do by the 29th of April. We've tried to produce some frequently asked questions that we'll be hoping to publish on our website in the next couple of days, actually, just to give information to businesses in terms of manufacturers, what they should be providing, and retailers, what they should be asking from their manufacturers of their products. But to me, it really shows that it's so important to engage industry and consumers at a very early stage to get the policy right, but also to make sure that other agendas are taken into account. So safety, security, sustainability all go hand in hand, and we need to look at the product in the round rather than just specific isolated issues. So it was a good example, and hopefully it'll work out all fine. So
thanks a lot. It was really an interesting approach, and I fully personally share also the need to cooperate on a very wide range. And this actually brought also an idea for which I would like to ask from Jesse, because you mentioned very interesting foreseeable concerns related to the new technologies, and showed some example of standardization and also guidance work. So I wonder if you think that the concerns you raised could be answered by standardization, and what's your view on this?
Could you repeat that question again?
So sure, if basically the concerns you were mentioning in your presentation, if this could be replied by future standardization work or notices or guidances, what is your view on this?
It could be standardized by guidances, by various documents and things. Like for example, the ASTM 3463. I mean, I'm not able to share the specific language of it, but we're looking at is what we're doing is we're looking at enhancements of risk assessments, right? We are also looking at data biases, model behaviors, consumers' understandings of the technology as well. We are looking at fail-safe modes based on adversarial simulated real-world conditions. essentially trying to create a foreseeable condition that it fails in a safe way.
Thanks a lot. It looks interesting for the future. And then finally for Tatiana, I wanted to ask, how do you see, because you were stressing a lot about the horizontal nature of the AI Act, so it's also maybe interesting for other jurisdictions. How do you see interaction between horizontal rules, horizontal AI safety rules, and product-specific requirements?
Thank you. And I'm cautious of time, so I will reply. So standards will definitely play a role. As you know, also based on AI Act, we issue standardization requests, and we work very closely with ISO and Sensenelec. So it will be, in my opinion, like foundational layer, which of course then would need to be fine-tuned through product-specific legislation and standards. So my reply is that I have to thicken layers, you know, and build it like layer by layer. So of course we cannot resolve with one. There is no golden bullet, you know, silver bullet to resolve everything. So, but there are a lot of questions to work on for sure.
Thank you very much. And definitely, I think this session was really a good example of how many issues and how many potential risks are related to future and new technologies. So I would really like to thank all our panelists for taking the time and explaining and sharing their experience with us, because it was really a rich discussion. And I would also like to invite them that for those who you see in the Q&A questions on mental health and you feel ready to reply, please respond in writing. But this would bring us to the end of our session, and I'm very much looking forward to the new session, which will be about actually tools that will be able to identify and assess digital technology and safety risks related to digital technology. And we will start this session in 5 minutes, so you can all stretch a bit your legs, have a coffee, and we should be back in 1:50 Paris time. Thank you very much for everyone.
Hey, hello everybody. Welcome to the third session. Sorry, excuse me. Now, welcome to the third session of this workshop, and thank you for coming back to the third session in this workshop. I would like to all panelists for this session to turn on the camera. Okay, and let's start. My name is Minyoung Ha, head of injury information monitoring team at the Korea Consumer Agency. I will be the moderator for this session today. Before we start these sessions, I just want to say some things. The digital technology is evolving, and digital transformation is very, very increasing now. But there's still conventional customs. The day after tomorrow is Lunar New Year's Day in Korea. So I just want to tell everybody Happy New Year today. Shall we start now? Well, the session will involve an examination of tools that are or could be used by regulators and other stakeholders to identify and assess risks relevant to product safety and digital technology consumer products, and consideration of how such tools may need to be adopted. We have a great set of panelists. They are Marko Grobelnik, co-reader, Artificial Intelligence Lab, Slovenia Josef Stefan Institute, and also a member of the OECD AI Network and Network of Experts. Irene Kitsara, she's the director of European Standardization Initiatives at the IEEE Standards Associations. Simon Lee, electrical engineer, Division of Electrical Engineer and Fire Scientist at the CPSs in the United States. Professor John McDermott, software engineer at the University of York. And finally, Philip Priest, head of risk curve intelligence at the UK Office for Product Safety and Standards. I would like to note that in the agenda, we originally had a 6 panelist, Arina Olszek, who won't be joining us, as Marco will also be presenting content on her behalf. As with previous session, I'm first going to invite each panelist to provide a presentation of 7 to 8 minutes before I open the floor up for questions and answers. We are gonna hear first from our product safety regulators on their risk assessment tools. Phil, would you please take the floor to present the UK Office for Product Safety and Standards Product Safety Risk Assessment Methodology and how it applies to digital technology products?
Thank you very much. I think I have some slides which somebody's going to put up. If I could just have my slides, please. That's brilliant. Thank you very much, and good afternoon, everyone. I'm very pleased to have the opportunity to speak with you today. What I'm going to do in this session is talk about the fairly new product safety risk assessment methodology, or PRISM, that the Office for Product Safety and Standards has launched just over a year ago. And that's for use by product safety regulators in Great Britain. I'll give an overview of PRISM, and I'll talk about risk assessment in the context of digital products. Next slide, please. This slide gives a high-level overview of PRISM. Risk assessment is at the heart of PRISM, stage 3 there, but PRISM is actually broader than pure risk assessment. And the process typically starts where we have a non-compliant product or a product we have concern about. If there's any doubt whether a full risk assessment is needed, there is a triage process that tells you whether it is. Then we have the risk assessment itself, which comes in 2 parts: preparation and then undertaking the risk assessment. Then we have risk evaluation, which I'll talk about later. Then QA and reporting, and then risk management where needed. Next slide, please. This slide highlights the main differences between PRISM and the previous methodology we used. Haven't got time to go through all of this today, but I'm happy to pick up on any points later on if anybody so wishes. Risk evaluation and tolerability I'll come on to. The last point is worth mentioning. Within PRISM, we've developed a range of additional guidance on key risk-related topics that we find risk assessors sometimes struggle with. So we're trying to help them in that regard. And I'd also highlight the bullet point in the middle, which is the risk. It involves consideration of the total number of product items in use, as well as a single product item, which I'll pick up on in the next slide, please. Okay, so on the table on the left, the probability of harm on the left is combined with the anticipated severity of harm at the top to give a level of risk somewhere between low and serious. And there's nothing new about that. That table appears in the EU Safety Gate methodology, for example. But in PRISM, what we also do is we consider the totality of the risk presented by all items of the product, this product of concern that we believe or estimate are in use across the UK. And that gives an estimate of the overall risk to the population. So what that actually means is where large numbers of the product are estimated to be out there, the overall level of risk can increase. Next slide, please. So PRISM includes risk evaluation, which sits between risk assessment and risk management. And it's needed because decisions on whether action is needed to deal with a particular risk and the nature of the action should not usually, in our view, be made purely on the basis of the level of risk involved, albeit that is fundamental. Other factors potentially need to be taken into account, and ultimately a decision needs to be reached on whether the risk is going to be tolerable to the public, and therefore whether risk management action is needed. Next slide, please. So in risk evaluation, we think about the nature of the risk more broadly and consider whether the factors listed on the slide there might influence whether risk management is needed and what it should consist of. And I won't go through all these now, but I think the top two there are particularly relevant for today's workshop, especially the potential for psychological harm. Next slide, please. And risk evaluation involves consideration of the tolerability of the risk. So in general, serious and high risks are intolerable, low are unlikely to be intolerable. But it's not quite as simple as that. And there are other factors that need to be taken into account, such as those on the slide. And what they can mean, for example, is that sometimes a low risk could still be, when you take those factors into account, intolerable. Next slide, please. And as you might expect for intolerable risks, risk management action is required to deal with them. For tolerable risk management action is not normally required. Next slide, please. And this slide simply shows the additional topics that we've provided the additional guidance on within PRISM. And psychological harm, as you can see there over towards the right on the bottom, is one of those topics. Next slide, please. So thinking about this in the context of digital technology, traditionally, I think it's fair to say that in the main, product safety risk assessment has concentrated on physical harm. And by that, I mean injury and ill health such as dermatitis or exposure to toxic chemicals, something like that. PRISM does the same. But in developing it, we also recognised that we needed to go further. The problem was how. We knew that some products, such as connected products, can result not only in injury and ill health if they're non-compliant or if they're compromised, but they can also result in psychological harm, stress, worry, emotional damage, as it were. And compromise can result in financial detriment to consumers and loss of privacy and reputational damage, etc. And that might involve not only the user of the product, but others that might be exposed to it. So we considered assessing the risk of these types of harm in the same way as we assess the risk of injury. But that proved very difficult for a number of reasons, which I think can best be summarised by a lack of clear evidence on how to deal with those harms in the context of risk assessment. So in effect, we went for a halfway house in that we included consideration of these harms in the context of risk evaluation, but not risk assessment. So within PRISM, where we feel there is potential for a product to cause, say, psychological harm or financial harm, that should be noted within the risk evaluation narrative and might influence the need for corrective action to be taken. But looking to the future and the rise of digital technology and the range of hazards that come with it, I think there would be benefit in developing or including these other types of harm within the risk assessment process. The challenge, as I say, is how. And the challenges are many. So, for example, how would you grade the degrees of harm? You could argue that in terms of injury, for the most part, a broken limb is a broken limb, a burn is a burn. And you can have a fair idea how serious they are for any person. But in terms of, say, a financial loss of, let's say, £1,000, wouldn't that be less severe for a rich person than a poor person on the breadline? And in terms of the causes of psychological harm, and I'm no expert on this or indeed digital technology, but I think it's fair to say that it's quite specific to the individual. So a hazard that might cause quite severe psychological harm for one person might have little impact on somebody else. And for example, with our broken leg and our burn, you can have a pretty good idea how long it might take for a person to recover from that sort of injury, typically. But for psychological harm, one person could recover from the same sort of psychological harm quite quickly, whereas for another person it could last a lifetime. Next slide, please. Okay, finally, just a few words on consumer perception and connected products. There's been research into this issue, not least research commissioned by my colleague Magda Osman at Cambridge University. And to summarise very briefly, the Cambridge research found that people tend to be suspicious of novelty. So traditional, not connected products tend to be viewed as less risky than their smart or connected equivalents, and any potential risks are more tolerable than with their smart equivalents. The research found that people tend to be more likely to place blame on the manufacturer when a connected product goes wrong, and the route of purchase of the product, so whether it's bought online or offline, doesn't seem to make a great deal of difference in terms of the risk perception and tolerability of a connected product versus a traditional product. So there's no difference. There was no difference found in attribution of risk in terms of where the products are bought. And I will stop there. I think I've used up my time. Thank you for listening, and I'll hand over to the next speaker.
Thank you very much, Phil. That is very impressive and informative presentations. Now I'd like to invite Simon to present the US CPSC's approach to assessing the risks of products incorporating artificial intelligence and machine learning. Simon, the floor is yours.
Oh, thank you so much. Good afternoon, good morning, everyone. I'm honored to join everyone. I'm going to share my screen. Let's see. Give me a second, please. So just speaking, thank you so much listening to the panels that have gone so far. You know, we're a United States Consumer Product Safety Commission, and we look at down to the product level. We have tools for risk assessment, risk management. We have a program that we look at it from the top level. But we try to go down to the product level for testing in our lab. We have a lab and a headquarters, two sister sites. So we attempted to establish a test and evaluation program. It's in its infancy. Everything we're doing now for these emerging technologies is using a proactive approach. We want to get ahead of the curve, of course. Everything, AI, ML is moving so quickly now, everything in the news now at certain ChatGPT and such. But, we're getting ahead of it for a proactive approach. So we're going to lay out a little bit of a proposed T&E program. It started around 2021. We had 2 public forums where we establish, where we traditionally establish a program. We collect data, we have stakeholders, experts, and standards, what's out there, policy, test and evaluation. So we had those 2 forums, an initial forum to gather information, and then a more of applied forum for test and evaluation to apply what we learned from the first one. And those 2 reports, 2 public reports from those forums. I'm going to attempt to actually try to share something else. I don't know. Hopefully this works, because my slide got kind of, through our clearance process, got reduced through some compressed timelines. But I'm going to see if this works. And this is public knowledge, so if you all are interested, I can send the links out. Hopefully y'all can see that. Can folks see that? Okay, thanks. So of course this diagram is hard to present because it's a lot of information here and there's limited time. First we want to go through a screening process. And these are the steps to see if something's AI capable. And there's another one actually to go into machine learning. There's debate about AI, ML, if it's separate, if it's a part of each other. AI can be a broad term and then ML can be a subset. But we chose to look at each of them because AI can apply to a lot of different technologies. Machine learning, is a lot of data, a lot of decisions, modeling on that data. So, common components, IoT, common, more connected products as part of this. You have a data source, sensors, and you have, very aggressive computing power to have all that data. And you have information, those algorithms, and then you have connections. Sometimes IoT is the sensor and it's also the actuator. So this is even to go through this process to see if it's AI capable. And then we have a machine learning process also, and that's for that a lot of data, a lot of that training, testing data, we call it. And that's to see, you know, monitoring if it has those sensors, and it has measuring, you know, kind of seeing the differences of that modeling to see if the input is, you know, it's tracking that input of a sensor of a microphone. And the measuring is to see the differences between that input. And then modeling is, you know, the algorithms, you know, seeing if it makes decisions on what it collects. And it goes around in a circle, you know, because it can change, it can evolve, which is it's just a key factor that folks have already mentioned that we have to make sure we account for. So it's a screening process. We have it's called a SAAM. You know, it's a neat little acronym. Part of that first S is screening. And then we have assess, analyze. You know, assess is the second step, if I'm getting this correctly, because I'm scrolling around, making everyone dizzy. Assess, analyze. Assess is really to make sure you have these AI components, and you can really isolate those AI components, because there's a lot of different components. You know, the analogy I use is we have autonomous vehicles are so much in the news now. You know, they have a lot of different components: sensors, computer vision, everything to aggregate that data, and you know, to output the actuator to move the vehicle on its own. So we have that assessment to isolate each of those components. You know, what I kind of showed before about all those different components, and then analyze is really the testing, the heart of it. Assessing is the getting the test plan together, getting those different components. Analyzing is actually testing. Monitoring, measuring is going through to see if there's differences, see if it's evolving, for the evolving part. So of course, as I mentioned before, it's very, very much in the infancy. We had a pilot kind of run through of our process where we went through baby monitors. We wanted to see if SIDS, went through SIDS. You know, SIDS is very debatable whether or not it's through breathing, whether it stops breathing. There's data on that. We looked at all those characteristics data. We finally decided, just for argument's sake, that if the baby could roll over, we had a lever if the baby could roll over, and we measured each type of lever. And then eventually the baby would roll over a little bit, would roll over a lot. And we had about 5 baby monitors, all different types. Most of them are closed loop systems, Bluetooth, not going out to a back-end cloud, because we want to isolate on the device. You know, a lot of it's on the device processing is a trend now. And also, of course, all the cloud computing power. That's so much, that's also very important. So we want to isolate from the cloud and backend. We want to try to do as on devices as possible, isolate those variables and those components. So we went through our test process, which is basically just going through all the different test variables and then isolating them, going through what we call a phase 1, which is trying to get one variable and isolating it and going through each iteration. The type of testing we typically do at CPSC, US CPSC is as a system test, an input-output. We look at it as a system. You know, what folks have probably been mentioning, there's limitations on proprietary software and algorithms, models. You know, there's in the news now how they use the different machine learning models, and they can even lease them or lease them to a small business company that can use those models, and people can trade off on those models. But anyways, those models are very hard to actually dig into and go into lines of code. So this proposed T&E program does more of a system test, and it goes input, output, and isolates those variables. And then later on, we mostly did a phase 1, isolating different variables, and we chose to talk about temperature monitoring, because the different baby monitors did temperature monitoring. They could use different sensors. You know, they have various different sensors. They have like a it could have a sound supersonic sensor. It could have a you know, the FLIR cameras. It has that type of sensor also. It has all types of sensors. So we wanted to isolate the temperature detection of the different baby monitors. And some were like a wearable device. One was a wearable device that could hook on the baby's stomach. One was just a camera. You know, I actually have that type of camera that just looks on my baby and it's on my phone. One was like that. And it used, you know, what I mentioned, like kind of FLIR temperature sensing, different images, it kind of does computer vision. So we did the temperature measuring. We chose that as our main component. and we went through, stepped through that way. Going back to my slide, hopefully this works to jump around, make you guys dizzy. So yeah, this lays out what I just mentioned before, where that screening process of the first letter of SAM, and then we have the assessment and analyzing, and finally the last to see if it evolves. So our key for CPSC, our jurisdiction is physical safety hazards. We want to see if someone gets shocked, you know, fire hazard, laceration. So we want to do like a second order effect. If the AI ML it causes a safety hazard, do that second order effect. Because that's not our jurisdiction. Our jurisdiction, you know, you can see in our IoT presentation later, that's not our jurisdiction for the cybersecurity, but we want to see if it affects the physical safety hazard. So that's mostly it. Thank you so much. We appreciate the time.
Thank you very much, Simon. It is very informative and very fruitful presentations. Now, I would like to offer the floor to Professor John McDermott, who has some other perspectives to offer on the frameworks to assess AI and machine learning and products. Professor John, you have the floor.
You'll need to unmute, please.
So hopefully, can you see the proper presentation mode now?
Yes, we can see.
Yeah, good. So thank you very much for inviting me. Can you hear me okay?
Sorry, we appear to be seeing it in presenter view.
Okay, I'll swap it around. Hang on a moment. Is that better?
Perfect, thank you.
Yeah, thanks. Apologies for that. So, like Simon was talking about digital technology, I'm going to focus on AI and machine learning. I've run a program looking at safety of autonomous systems, especially those using AI and ML, funded by the Lloyd's Register Foundation over the last 6 years, and they've just supported the program for another 5 years. I'm going to come to you from that point of view, and want to try to make 3 rather different points. First, although I'm not a lawyer, I work with lawyers, and I think the legal context for this is really quite important. And actually, the relationship of AI and ML with existing legal mechanisms is really rather problematic. And it's not just a single area in tort, contract law, sale of goods, criminal law. There's often very significant legal responsibility gaps for harms. And largely that's because the law requires on establishing causal relationships between the individual, the legal individual, maybe an organization, responsible for the harm and that actual harm. And so by comparison with the non-AI ML technologies, that's really rather difficult. The fatality of the Uber ATG vehicle in Tampa, Arizona is a case in point. Uber were found not to have a case to answer under Arizona law, but the safety driver was prosecuted. So, you know, that's one example. There are many others. Of course, people have noticed these gaps, and there's work on reframing laws. And, you know, one example is the EU AI Act. I think it's unlikely to be sufficient for at least 2 reasons. One, they've given very explicit descriptions of what you think AI is, which in a technology is moving so fast, I think is only going to guarantee that it's inaccurate, not encompassing in the future. And the way they dealt with more critical systems is, I think, at best confusing. At worst, actually makes the situation easier for critical systems, not harder. And I think we're likely to need soft law as a mechanism here. So these are more industry and community-based approaches which can evolve quickly as the technology evolves. And that might be uncomfortable for regulators, but I'll come back to that in a moment. That I wanted to say something slightly more technically. The program I've run for the last 6 years has produced an assurance process for machine learning called AMLAS, Assurance of Machine Learning for Autonomous Systems. This provides a systematic process for evaluating the safety of machine learning, set of defined activities and evidence artifacts that you use, which then feed into safety argument, a safety case. This is not, that's a widely accepted practice all around the world, but in the UK, particularly following things like the Health and Safety at Work Act, we tend to make use of safety cases to demonstrate the safety of systems prior to deployment. I'll explain the diagram very briefly in a moment, but to say I think one of the powers of what we've done is this framework is actually quite generic and it can be tailored for use in different domains. So it's been picked up by the relevant healthcare authorities in the UK, the MHRA, amongst others, working with the BSI and others on standards for autonomous vehicles, reflecting this. So one of the things before I explain the diagram, it's very easy to say that, well, people develop AI and then we must test it as a black box. I think for things that are really safety critical, that's insufficient, and our process assumes or requires more intimate involvement in the development process. But in essence, there are 6 technical stages here. The first is safety assurance scoping. So imagine I have a humanoid robot. One use case is in a factory. The other is social care setting, a residential home for the elderly. Actually, the safety requirements and the constraints can be very different in those 2 different domains. So we need to set that out. From there, we'll work out what safety requirements we have on the system. Then steps 3, 4, and 5 are the 3 core steps of the machine learning development process, gathering data, which is really critical. If we train systems on inappropriate data, we'll get inappropriate and potentially unsafe behavior. How we learn the behavior of the system and then how we verify that. It's also important then to understand how that system is deployed. So the model deployment assurance is looking at how that ML model is then actually used in practice in the real world. And so I have a systematic process here. The first slide had a link to our website, and I'll make sure I share a final version of these slides with the Secretariat so they can make those available to others. The other thing I want to talk about very briefly is about governance. When technology moves very fast, by and large, regulatory processes don't. We need to be much more agile. But just to make that concrete, I mean, one of the most common safety standards for technical computer-based systems, IEC 61508, took 13 years to get to the first issue. You know, that sort of time frame is just impractical given the pace of change of technology. So what I've developed with a number of other colleagues is this idea of a sort of 3-level governance model. If I start at the bottom level, this is what we call task and technical. So there's some AI-based system called the managed system here, which is going to be monitored and managed either by a human supervisor or by a technical system or by both. But we have the system monitors the environment and affects it, but actually the managing and human supervising systems also look at that to try to make sure it's behaving as we wish, safely, ethically, whatever, and can take corrective actions. But there's a higher level of supervision by the organization responsible for developing, operating, and sustaining that system. And here we'd expect there to be a safety management system that actually oversees that, and the safety management system would be adjusted as necessary if operational behavior turns out to be different what we expected. Now, I think this will have to evolve fast, and I think this may be one of the areas where soft law agreement between companies in a particular industry, what's an appropriate level of control. And then the top level, which is actually where many of the organizations familiar to us, like the OPSS, would sit, where I think again they need to actually monitor the industry as a whole, but also to impose rules and regulations accordingly. Again, if I just sort of very briefly go back to the EU AI Act, it says that certain uses of machine learning will be banned. If I remember correctly, they banned things around facial recognition. There are actually use cases where that's valuable because you can assess intent of people where they might actually be in positions of harm. So I would expect the regulations up here to be much more subtle and saying, well, actually, in this case, the privacy risks are outweighed by the safety benefits, so that should be allowed, rather than to take blanket decisions. And this, I think, will be really challenging for regulators. It probably involves a deeper understanding of the capability of these systems that they've had to have hitherto. I think this is the only way to sensibly regulate and manage this class of technology. So I'm happy to take questions later on, as I will make the slides available, so you've got web links to where you can find the extra information. And with any luck, I can actually exit from this, but it's not being very kind to me. Sorry, I'll try to stop sharing in a moment. Oh, there we go. Have I got out? I have. Good. Thank you.
Thank you very much, Professor John. It is very interesting presentation about especially AMLAS and governance process.
Yeah.
That is very impressive process, and then very very good informations. Then thank you very much again. This is now a great moment to bring in Marco Grobelnik, who has been very involved in the development of the OECD AI incidents monitoring tool, and further work to develop an OECD incident reporting framework, which could both potentially be used more in the product safety area. Marco, the floor is yours.
Yes, thanks very much. In a way, my presentation will complement Simon's and John's talk in presenting pretty much very practical work, what we do at OECD for last, I would say, like 2 years, and which is slowly kind of converging towards kind of more like standardization and practical results, which I hope I'll be able to demonstrate. Okay, let me share the screen. So I have a couple of slides, and towards the end I will switch to live demo. Okay.
Marco, we're not seeing them in full screen. Ah, perfect. Thank you.
No, it should work. Yeah. My function key was off, right? Okay, so as said, so I will present this briefly. It's a lot of material, but briefly, the OECD AI incidents framework, and this is work up to date, right? So it's continuing, and many of the things which you will see will still evolve, but I mean, we already kind of feel that the work is converging. Right? So I will try to cover 3 topics. First, the definitions of AI incidents and hazards, right? So this is let's say, the name of the game. The second thing is this common reporting framework for AI incidents. So somewhat interoperable schema of features which would be used to describe incidents and report back to policymakers. And the third one, this will be more like a live demo, AI incidents monitor, so real-time tracking of AI incidents. Okay, let's go first to the definitions. So what you see here, it's a kind of graphical representation of schema, the way how we approach it. So on the right side, you see the OECD report on stock taking for the development of AI incident definition. So here we took like 30 frameworks from across the world and analyzed them, and somehow out of this we kind of elicited the schema which seems like might be quite appropriate for AI. So what you see here graphically, so on the left side you see the potential harms, right, which includes basically hazards, as we would say. So hazards are non-materialized potential incidents, but they didn't materialize yet, right? So this would be like AI hazards and serious AI hazards, so two categories. While on the actual harm, so incidents, we have AI incidents, serious AI incidents, and AI disasters, which so far didn't happen, but let's say it may happen. They may happen like in the future, right? So this is the top level schema. Now, for each of these boxes, we have written definition. Now I will show only one, which maybe we can read just so that this is the lower right box, right, which is like the most common AI incident, right? Maybe we can just read this together so that you get a feel how we approach the AI incident. So an AI incident is an event, circumstance, or series of events where the development, use, or malfunction of one or more AI systems directly or indirectly leads to any of the following harms. And then we have this: injuries or damage to the health, disruption of the management and operation of critical infrastructure, violations of human rights, and damage to property, communities, or the environment. So this is like sort of high level, right, definition of AI incidents, which was discussed like for last 2 years. And we are now like aligning this towards AI Act and other related kind of frameworks. So this is just to get you a feel. Like on the next slide, which doesn't show here, is our definitions for the rest of these boxes of the schema, right? So all these are kind of defined, right? Okay, let's continue now. So once we have a definition or definitions, right? So we want to develop this common reporting framework, which would be able to describe AI incidents on one side in a practical way, and on the other side in enough expressive way so that we can capture everything what's kind of relevant, right? So as we took like 4 key frameworks as a baseline. So OECD framework for classification of AI. So this is our previous work at OECD. Then AI incidents database, OECD global portal on product recalls, and AI incidents monitor, which is kind of the practical side, which you will see a little bit later. So out of this, we kind of extracted a database of 88 criteria along 8 dimensions. Here you see these 8 dimensions and how many criteria each of the dimensions contributed into this, let's say, database, right? Now, 88 criteria is a little bit too much to describe an incident. So we reduced this 88 down to 25. This is the current working version, which likely will change maybe a little bit, but probably not too much, right? So out of 88, we extracted 25 criteria. So there were different kind of filtering stages how to what we extracted here for this 25. Basically, the first 6 are obligatory, the rest less. But may happen that some of these criteria will get also a little bit more refined structure, right? Okay, so this is the current state of this common reporting framework. Now the last stage, this will be live demo. So here I will show this what we call AI incidents monitor AIM, which has basically two functions. One is tracking of AI incidents in real time from mainstream news. And the second one is more like manual reporting of AI incidents based on the schema which you saw before, or in kind of a little bit simplified schema. So this is still ongoing work. So I will show more like this, the real-time monitor from news. Maybe some of you might have questions why we are using mainstream news, not something else, right? Because simply doesn't look like that. There is something else. Mainstream news seems like the only kind of sensor, global sensor, where we can detect what's kind of at least serious or serious enough to be considered as an AI incident at the moment. We don't see other sources. As said, the second source will be manual reporting, voluntarily or obligatory, mandatory reporting, which may happen in the future, right? Okay, let's switch now to the actual demo. The title is OECD.ai/incidents. You get the main screen. So what you see here, basically, it's kind of a search engine over the incidents which we collected. Maybe this graph is interesting. So this is, you see, it starts from 2014 and goes till today, pretty much. And this is how many reports we collect per month. You see that after ChatGPT moment, mostly, or after generative AI in 2023, number of detected incidents went up seriously, right? So now in this recent stage, we collect, let's say in January, so previous months, we collected like 774 incidents, right? So which is a lot. So altogether, in all 10 years, we collected like 8,000 incidents for which were supported by 46,000 mainstream media articles, right? So as I said before, so just last month there were over 700 incidents of different kinds, and we collected 4,000 articles. Okay, so it's a lot of information, right? So that's why we need to have a kind of search engine. Let me maybe first show you just one incident, so one which is on the top. So this is from a few days ago. So finance worker pays out $25 million after a video call with deepfake chief financial officer. Okay, we click on the incident. We get a quick description of the incident, then justification why this is an incident. Then each incident we classify along this OECD AI principles, industries, affected stakeholders, harm types, and severity, right? So this is classification. And then for each incident, we have a set of reports from different mainstream media. So here we have, I think, 18 or something like this of reports. Maybe we can click the first one. So it's a CNN report on this particular incident, and you get to CNN page, and you can read what they wrote, right? So this is an example of an incident, right? If you go back, just let me. If we go back to the incident monitor, right? So we have also advanced, since every incident which we identify, we label, annotate with different schemas, right? We can also search over these schemas, right? So, okay, we can search over time, fine, this is easy. Severity, death, injury, hazard, non-physical harm, so these are these categories. We can search per country, We can search per harm type, physical, psychological, and so on, right? Per industry, affected stakeholders, or OECD AI principle, right? And for instance, if we make a quick search now, let's say minorities, right? Now we get all the incidents related to minorities, and we would get some of them, like AI and the human body. Hidden assumptions in motion capture can have serious impact. And then there's a set of reports on this, and many more, right? We can also search, well, through the search box, right? So if we say here, what else than ChatGPT, right? So we say ChatGPT, make a search, and we see basically from 2023 January how the number of incidents per month related to ChatGPT kind of increased, right? So, and then below you would have the actual reports. So much, not to be too long, right? So we are extending this monitor to the version 2.0, which will be even more comprehensive, and probably will also expand the number of sources. Even now we have like 150,000 sources. It's just at the moment it's not cross-lingual, but we'll make it cross-lingual so that we'll capture also non-English reports. Okay, thanks for now. And later, I guess we'll have a little bit of discussion on this. Thanks.
Thank you very much, Marco. It is very impressive information, informative presentation. Especially from the demo, it is easier to understand how AI incidents are categorized, but nevertheless, it still seems difficult to accurately categorize if this is an AI accident intuitively when a incident occurs in real time. So, yeah. Thank you very much, Mark, again. Finally, I would like to bring in a broader view on possible standards and frameworks to assess the risks of different digital technology products from an industry standards perspective. Irene, you have the floor.
Thank you very much, Min-Young, and thank you very much also to OECD for the kind invitation. Let me share my screen. So we have already heard earlier today about the changing landscape in consumer product safety, and embedding or integrating digital technologies into traditional consumer products is something that has been picked up. We heard earlier about the general product safety regulation, which makes specific reference to new technologies, and also the fact that there are new paradigms now is shown by the fact that both the US and the UK are establishing or have established AI safety testing bodies. So we are observing a convergence of different technologies and integration into products, a combination of different digital technologies that may have been existing but maybe have not been applied in specific industry sectors. And we also observe a type of convergence of product types. So as we are increasingly using additional or new sensor types to give more functionalities to different consumer products, there is an increasing, there is a convergence, or we see a behavior of medical device alike assessments or functions of classical consumer products, and that is posing, for example, a number of risks, increasing a number of risks We have seen wearables or, for example, wellness applications which are not tagged as medical devices or medical device software, but they may be used for measurements that consumers may be indeed using to monitor their health metrics. And unlike other products, they are very difficult, so the producers cannot really recall them. So there are some issues there with risk. We also heard earlier about a different examples of AI embedded in different products. We also observe an evolving concept of safety. We heard before that it's not just the traditional implication of or understanding of safety as electrical safety, which was translated in the traditional standards that we know at IEEE traditionally on power and energy, on electric and electronic engineering, and we may have seen certain implications or safety which related to health risks, such as, for example, the CN95 IEEE standard group, which relates to safety levels, exposure to radio frequency electromagnetic fields, or another one setting standards about what are the acceptable flickering range or for LED, which may otherwise be causing some health implications. But as we heard earlier, there is an increasing concern about potential impact about the use of consumer goods on mental health, which is, by the way, very difficult to measure and assess, and there are no commonly accepted standards on that. We have heard earlier also about the presentation about the metaverse and VR wearables, and I had the chance to lead a study on that with the Council of Europe, where the participating experts were raising exactly these concerns that a lot of the sensors may have been used for a specific with a specific intention, but for a number of new applications or new products, we don't know the long-term implications and impacts on health, physical, psychological, or mental, or the cognitive functions, and we may have some indications now. So at IEEE, we have, beyond the traditional standards, we have developed and embedded into the technical specifications and requirements, also some socio-technical standards and some ethical considerations, which have been translated in a series, for example, of standards related to the design of AI systems, like the 7000 series, which is all about value-based design of AI systems, and which tends to be a bit more agnostic. So we can, talking about, you know, the quick developments, this can undervalue the product developers, and also the regulators could decide to know which could be these values that should be translated and embedded and integrated in the design thinking of the AI systems, if we were to talk about AI. We also heard earlier something being mentioned about, you know, that these digital technologies, they are not only a potential cause of harm, they can even be used at the service of risk assessment and product safety. So we have been seeing a lot mixed reality engineering with the application of digital twins for different scenario analysis, and trying to identify the different range of consequences of a technology or of a product. And we have also seen on the IEEE side, for example, there are even currently there is a recommended practice about the impact of AI systems on well-being. So there is even a translation of an effort to see, set some criteria to measure across the life cycle of the AI systems the impact that they can have on the human well-being. Now, I would like to use another example, which was mentioned before, about the autonomous vehicles. And since we are talking about tools, and if we see the standards and conformity assessments as tools, use an example that shows where things are heading towards. So we are facing the challenge. So when we are dealing with a consumer product like a car, which has a very major safety implication linked to that, when there are updates in the software with some requirements, like, for example, the vehicle will be somehow wirelessly connected to the grid or to the wireless communication stations, there's going to be there is a limitation. So the system may be using AI, but it never learns. It never becomes improves because that would cause a concern for safety. And typically, when there is any change in the updates, for example, of a system, which would imply that we would change or add a function, there is the type approach. So the vehicle needs again to go through a new approval stage. So a current use case that is being under investigation is whether how we can move from the advanced cruising we all know to the lane change. So for that, for example, normally it would have to go through approvals, and that is not very convenient for changes that may be on one side critical, or in some other cases, it would mean that the user cannot use their car for a certain period of time. So when we are moving from the conventional to autonomous driving, which means that we start considering a car as a system, there are currently efforts. There is a UNECE recommendation, and the International Alliance for Testing and Standardization, where IEEE is a partner, are currently working on virtual homologation and automated scenario-based simulations for AVs. So the idea is that in the future, this process will be automated and still safe. There is also a series of standards around functional safety. For example, the IEEE 2846 or the project standard 2851, which deal with standards around assumptions in safety-related models for AVs, or how do we deal with dependability engineering across the life cycle of automatic vehicle. So when we are dealing with either interconnected devices in cases of IoT, or interconnected data and several technologies, sometimes the risk is not the equivalent to the risk which we may have assessed for each individual technology. We need also there are increased interoperability, vulnerability, and safety challenges when several technologies are either connected or embedded in a product. And there is a need for a holistic approach to risk and impact assessment. So often we start hearing more and more discussions around, for example, human rights impact assessments, ethical impact assessments, and the pure technology impact assessment that used to be like a standalone is starting now to, there are all these discussions and around the need to be a bit more holistic and consider the health impact assessment, of course. There is a need for new, adapted, or more responsive tools. We heard before about the need to be more agile when we deal with risk assessment and standardization, because we have the problem of catching up of regulation, standardization, risk assessment frameworks, and validation approaches. And To that end, standards and conformity assessments and certification can be used as support tools for regulators. For example, there is one standardization project which deals with the procurement of AI systems, and it includes also, among others, a stage around the critical evaluation of technical solution with a respective impact assessment. So it starts even, the idea is of including at different stages of decision making and impact assessment and evaluation of safety risks. There is a need for coordinated efforts because we are similar to the AV problem. This is a too big to solve issue for individual entities. So there needs to be collaboration, and at the same time we need to have a balancing act between, you know, the innovation, not stifling innovation, but at the same time regulating enough, having the standards that are recognized by the regulators as very important for the technical implementation of the regulatory requirements, and bearing also in mind both the safety but also the user experience while using that. Another point I wanted to raise was around the profile of the users using the consumer products. And I wanted to just mention the children. So we have an age-appropriate design standard, and often we see that consumer products, they may have a recommended age, and they may have a verification of age, but the impact we heard before about the different indirect harms that may be caused to different users. So if we're dealing with developing brains, if we're dealing with children who may not have the same maturity, we need to take that into account when from the safety point of view, and treat children as a different set of users. Lastly, there are these tensions between the sector-specific regulation, like industry-specific product safety regulations versus more horizontal regulations like AI. And that is going to be very interesting to see where this is going to move towards, if we're going to be seeing more goal or objective or risk-specific regulations and standardization, or whether we will be seeing more verticals of AI meets the different applications. Thank you very much.
Thank you very much, Sharon. That concludes our roundtable presentation, and I would like to open the floor up for discussion. I think in a Q&A board, there's one question for our panelist, Marco. Did you use Gen AI to extract the information? And what process did you make sure the result can be trusted?
Yeah, good question. Of course, we did a little bit, but the pipeline was kind of long, maybe in 3 sentences. So we start with from 150,000 news sources. Let's say New York Times would be one out of these 150,000 sources, right? We get per day like 1 million news. We reduced it down to AI news. We get roughly 15,000 AI-related news per day. And this 15,000 news are then further reduced down to AI incidents or hazards news. This would be in the range of between 100 and 200 news stories per day. And then we kind of cluster them into incidents. And then once we have this, then we apply Gen AI for summarization and I think extraction of justification. I think there are 2 functions at the moment. So this is, but mostly it's more like traditional AI because the scale and the speed is so fast that Gen AI would be a little bit too slow these days still, and too expensive as well.
Thank you, Marco. Actually, I have a question for Phil. Within PRISM, how is the severity of a physical injury graded within risk assessment? And could you not use a similar approach for grading the severity of a psychological harm caused by digital technology?
Okay, so in PRISM, similar to other general risk assessment methodologies, and I hope it was clear in my presentation actually that PRISM is not, it was not designed purely to address the risk from digital technology, but products, all consumer products generally, and by a range of regulators. So within PRISM, we grade the severity of injury on a scale of 1 to 4, 1 being minor injury, minor cuts, burns, bruises, etc., through to level 4, which is serious injury, death, or life-changing injury. And when we developed PRISM, we tried to do the same sort of thing. We looked at doing the same sort of thing for psychological harm, and use it within the risk assessment process in the same way as injury. But when we tried to do that, when we looked at it in detail, the difficulties involved and the challenges, some of which I touched on when I was speaking, were simply too significant for us to sort of to be able to reliably and accurately grade the severity of psychological harm in the same way as we did for physical injury. So that is why we instead included psychological harm as a risk evaluation consideration, rather than trying to assess it in the same way as physical risk, as risk of injury.
Thank you. Thank you very much for all those questions. And thank you very much to all of our panelists for their great contributions. It was very interesting to hear about the opportunities and the challenges of applying risk assessment tools to digital technology products. Was the existing tools developed by product safety regulators, as well as those from other areas, such as AI incident monitoring tools and industry standards. We are now going to pause for a break, slightly a little bit longer break, but we look forward to your participation again when you return
Yes,
with
hi.
the fourth session at 3
Yes, yes,
15 p.m.
yeah.
Paris time. Thank you very much.
Thank you, Mingyu.
Hello, everyone, and welcome back from the break. My name is Jean-Emmanuel Simion from the Consumer Product Safety Program in Health Canada, and I will be the moderator for this fourth session of the workshop, which so far has been very interesting in my view. So in this session, we will hear very concrete case studies from regulators to understand better how consumer product safety issues related to digital technology are being assessed or addressed in practice. For this, I am pleased to have with us today Natalie Etrel, General Manager, Risk Assessment and Operations, Consumer Product Safety from the Australian Competition and Consumer Commission, ACCC. Ewan Fraser, Head of Engineering and Technology at the UK Office of Product Safety and Standards, OPSS. Simon Lee, who you met already, Electrical Engineer, Division of Electrical Engineering and Fire Sciences, Office of Hazard Identification and Reduction at the US Consumer Product Safety Commission. And finally, Jisoo Kyung, Manager, Injury Information Monitoring Team, Department of Injury Information at the Korea Consumer Agency. So first, welcome to all of you and thank you for your participation. Now maybe we will turn to Ewan first. So Ewan, how is the OPSS approaching emerging risks from digital technology, consumer products, and what are your key concerns? And also, are there specific technologies that you've already looked at in more details?
Thank you, Jean-Emmanuel. So just to set the scene briefly, the OPSS, the Office for Product Safety and Standards, is the UK's product regulator. We have two main priorities in regulation: to protect people from product-related harm, and as we've heard today, how we might redefine harm is very much on the agenda, and also to help compliant businesses to grow, which may involve sanctioning non-compliant businesses. Importantly, for context, we're also the policy holder for some of the laws on product safety. So we have an opportunity to change the framework in which we regulate. Next slide, please. Thank you. So one of the ways that we generate evidence to enable us to base changes to the framework on is to carry out research. And throughout our research program, we've been considering the policy and regulatory challenges of 3D printing, 3D printed parts for consumer products. And we started this in 2020. But we carried out a piece of work with two consultancies. And we have also latterly carried out a horizon scan, which is very soon to be published, which looked at 72 different technologies, many of which incorporated digital elements, and 3D printing was one of those. Of course, 2020 also saw the emergence of the COVID-19 pandemic and the response to that by governments, NGOs, healthcare agencies, and industry. In the UK, the response to the pandemic also included 3D printed PPE. This was created both by industry on a large scale and consumers and individuals. And today I'm going to talk about that technology and the ramifications of changes and introduction of digital aspects to the safety of PPE. So we've got this very real case study. I think I should say at this point that I'm not sure whether I have the answers. This presentation is designed to pique interest and generate discussion between regulators and industry, and we can all then work on the challenge and find the answers together. Next slide, please. So if I take us through the PPE example and some of the issues that OPSS has had to deal with. On this slide, we can see a concept, an American concept, I think, for a reusable piece of personal protective equipment, where 3D printing is used to optimize for the user. So part of this product is bespoke and uses scanning and printing to make it fit properly. We understand physical harms from products like this. They're well understood, they're well researched and mitigated by the current system, arguably. Our framework of policy and regulation is built around catering for these risks. PPE is the last aspect in the hierarchy of risk control, so it has to work. And the regulatory regime for PPE generally includes things like third-party assessment, physical testing and quality control. So this is a well-regulated product. How much of that happens when we're talking about 3D printing, decentralized manufacture at pace in response to very dire needs? I think digital harms have generally traditionally been separately dealt with. So we have the understood physical harms, digital harms, certainly in the UK, dealt with by different policies, different departments, different regulators and standards. Technology like 3D printing brings these differences together. So there's a question about how we as regulators and policyholders evolve, collaborate and act both to foster innovation, but also to cover any gaps left in this evolution. And we've heard from my colleague Phil on how we're updating our risk assessment protocols with PRISM to cater for new types of risk and harm when technologies come together. What about hacking? Again, we've heard earlier from John, what if bad actors come together and take over a network of 3D printers, so designed to do something good and turned into doing something not so good. Also, we're not talking just about the physical PPE, we're talking about data, talking about files, we're talking about decentralized manufacture, traditional supply chains being broken, and challenges therefore for the people that regulate those supply chains. How is assurance provided if the PPE might be created in the user's premises or home? That might not be third-party assessed or tested. Important to say that using a 3D printer to create PPE is not illegal. There's nothing to suggest it should be less safe, fundamentally. So we can say that it's legal and safe. But what happens when things go wrong? What if there are aspects with the files? What if I download the files myself and I create the PPE and I use the PPE, but someone has messed with the file, someone has amended them, they aren't doing what they are designed to do and what I think they might do? How do I report that? Who do I report that to? And if I'm the regulator, is my jurisdiction challenged there? I'm used to dealing with physical products. I now have a file that could have come from anywhere in the world. How do I deal with that? So this is a real potential scenario that the UK dealt with during the COVID-19 pandemic, and it really brings together all of the aspects that I've discussed so far. What it doesn't do, though, is add potential AI/ML elements. So if the human is removed from the room, what happens then? If I grow a beard, if I eat too much or don't eat enough, I might change. Can the system cope with that? Can the image recognition deal with that? Might there be machine learning involved that changes the shape and tries to, match me as the user? How do we deal with that as a regulator? So the confluence of technology forces policymakers and regulators to think differently and to collaborate. We had Simon earlier talk about first and second order risk and harm. We're now talking the second order. So the physical risk is well understood. The harm here might be to data, to finances, to the security of the connected devices. If we can have the next slide, please. So these are some of the UK mitigations that we have put or are putting in place against these new risks, harms from the introduction of digital tech. So we have a strategy as a regulator. We're compelled to horizon scan. We're compelled to speak with other regulators, with consumers, with industry, to keep us at the forefront of changing tech. We're reviewing our product safety landscape. Others have spoken about horizontal cross-cutting legislation rather than sectoral. That's something the UK is grappling with just now. We've consulted, we have feedback, we're considering that. How do standards work in terms of not just products, but processes and systems? And third-party assessment, which has come under scrutiny in building and construction products. How does that cope? From April, connected products will have to have more stringent controls. We can't have default passwords or easy to guess passwords, and OPSS will regulate that on behalf of another department. So this forces collaboration across UK government. And of course, we have AI, where the UK position is on safety primarily, but also with an allowance for growth and innovation. And those things aren't always an easy marriage. And we have to work out as a regulator and policy holder how to bring them together. So as I said, lots of questions, maybe not as many answers, but interesting discussion, I hope. And thank you for allowing me the opportunity to put some of that on the table.
Thank you, Ewan, and thank you for your presentation, which I think highlights very well the complexity of those topics and how and what regulators have to face and to sort out. Thank you very much. So now I am going to turn to Jisuk. So Jisuk, I understand that the KCA has done some work on mobile car sharing apps and related safety issues. And so we would be very interested in hearing more about your findings around that. Thank you.
Thank you for this great opportunity. And it's really nice to meet everyone virtually. So this presentation is about mobile car sharing applications and rental car safety research conducted by Korea Consumer Agency. Next, please. Next slide, please. Yes, thank you. Previous one, please. In this presentation, I will be covering consumer safety issues on mobile car sharing applications and rental car safety, especially focusing on IoT security safety. Next, please. Mobile car sharing service through smartphone application is very popular among Korean consumers because Korean consumers are interested in sustainable consumption and sharing economy. There are three major businesses that provide mobile car sharing service in Korea. So my agency, KCA, conducted a research and found some safety issues. When a consumer rents a sharing car through smartphone apps, there is a possibility of serious threat for IoT security safety. For example, no one actually verifies car users' true identity face-to-face when consumers use sharing cars, which means that there is a problem of identity theft or unlicensed driving by unqualified person, such as minors. Next, please. According to research by my agency, all three major mobile car sharing service providers do not require any identity authentication process except for only once at first stage of membership registration. Especially one business out of three was even more vulnerable because consumers can use car sharing service under strangers' name by only knowing user account information, for example, ID and passwords, because the business doesn't require any additional identity authentication. According to Consumer Injury Surveillance System statistics data, for the last 4 years, there were 27 consumer complaints cases on defective sharing cars that are specific for mobile car sharing service. In addition, there were 10 consumer injury cases caused by defective sharing rental cars. Korea Consumer Agency assumes that this is because return of the car is also done contactless, but by only mobile. Accordingly, car inspection, repair, and necessary maintenance are not done in right time. According to a consumer survey, 260 consumers out of 1,000 answered that they experienced the defective car when they used the mobile car sharing service through a smartphone. And 35.8%, which is a huge number of users, replied that critical components that can lead to serious car accidents, such as engine and tire, were defective. Besides, 497 consumers answered that there was no enough information on how to use rental cars from car sharing providers when they use car sharing service through smartphone. Then KSA actually conducted a safety investigation on 66 rental cars that 3 major mobile car sharing service provide in Korea. 24 cars out of 66 were defective cars. There were cars with no tire repair kit equipped with, broken lightning system, and tire pressure imbalance. Consequently, Korea Consumer Agency took corrective measures in order to deal with IoT security safety issues and rental cars safety of mobile car sharing service. First, KCA strongly encouraged service providers to introduce additional user identity verification procedure for car sharing applications, and business agreed to enhance IoT security. Secondly, KCA urged business to conduct regular car checks, inspection, and repair. Also, to provide detailed information on rental cars. Businesses agreed to cooperate to strengthen consumer safety. Finally, KCA announced results of the research and corrective measures by press release and social media in order to raise consumer awareness. Next, please. So this brings me to the end of my presentation. Thank you very much for your attention.
Thank you very much, Jisuk, and thank you for that presentation that showed a very concrete example of new problems and proposed solutions that we are now having. So now I will give the floor to Natalie for a presentation on how the ACCC is responding to the new risks emerging from digital technology consumer products. So Natalie, thank you.
Thank you very much, and thank you for the opportunity to be part of the workshop today. If we just move to the next slide, please. I'd like to cover 3 key areas. Firstly, our regulatory framework. Secondly, case studies, and I'll discuss some examples of products and issues that we've encountered. And thirdly, emerging issues in the future. Next slide, please. The ACCC is the national competition, consumer, fair trading and product safety regulator in Australia. The responsibility for regulating product safety issues associated with digital technologies, though, is a shared one across government agencies. And I think that others who have spoken at this workshop have also talked about that aspect as well to regulation. The ACCC's role under the Australian consumer law captures product safety issues in general consumer products. And then we also have state and territory governments that are responsible for product safety as part of a one law, multiple regulator model. In addition to this, we have specialised regulatory regimes for certain types of products. Examples of this are therapeutic goods, motor vehicles, electrical goods, and there's a range of others. And then beyond product safety, there are government agencies that have a broader interest in safety and policy issues raised by products with digital technologies. And as one example, the Australian government recently published an interim response to its consultation on safe and responsible AI in Australia. If we go to the next slide, I'll talk a bit more about some case studies. So we receive reports from a range of sources, from consumers. Suppliers also have mandatory reporting obligations and need to advise the ACCC of serious illness and injury incidents relating to products that they supply. We also encourage voluntary reporting of incidents that don't meet that threshold for mandatory reporting, because they may include near misses, and that helps us get a better understanding of particular product safety issues that might be emerging and we might not have visibility of in terms of the mandatory reporting regime. We look at recalls, and also more broadly, we look at not just recalls within Australia, but globally. What we've seen is relatively low reports of product safety issues connected to digital technology. But what was interesting to see as part of this workshop was the OECD's Global AI Incidents Monitor, and this looks like a really useful tool to help support our understanding of incidents occurring more broadly. And I thought this would be a good opportunity to talk about a few examples, particularly focusing on recalls, and these further details about these are available on the Product Safety Australia website, which the ACCC maintains. So the sorts of issues that we have seen when we have had reports and recalls notified to us, examples are, for example, in an e-scooter, we had an overheating risk which arose following a software update. And that software update risk issue was that it may cause the scooter's controller or lights to fail and the scooter to shut down. And the option to remedy that issue was a repair. We've seen an instance of a boat navigation system where a software defect could result in the boat being steered off course from the intended route. And the remedy in that situation was a software update. For a smartwatch, sensor issues that might short circuit, leading to the risk of skin irritation or blistering, and similarly a software update to remedy that issue. And another one, a dive computer, so the product did not automatically adjust the pressure level, which can lead to a miscalculation of remaining dive time and ascent procedure. And again, for that, similar to some of the other ones, a firmware upgrade was the remedy to address that. I might just move to the next slide, where we just consider some of the emerging issues and considerations for the future, and recognise that this will be an area of continuing interest. And there are a range of issues to consider, so I've just selected a few to talk a bit more about. In terms of regulatory coverage, we need to consider the extent to which our laws need to adapt to these issues. There are questions about whether the safety hazards that might occur in interconnected components are actually captured under our current regulations, which really focus on consumer products or product-related services. In terms of harm, we haven't seen consumer product safety reports where mental health, illness or injury was the catalyst for a report. And I listened with interest to the panel discussion earlier about mental health considerations. And it's clear that we need to consider scope for this type of harm and the ways that regulators may need to adapt to respond to these risks. In terms of liability considerations, as one example, consideration about the interactions between a consumer good and then a third party interconnected technology that may lead to illness or injury, and where the liability lies there is just one one instance, and I know that others at the workshop also highlighted liability issues. And then software updates. We have seen software updates, as I mentioned briefly in some of the examples, creating product safety incidents, but we're also increasingly seeing suppliers use software updates to address both digital and non-digital technology safety risks, which creates added complexity as we look to regulate in this space. So that concludes my presentation, and I look forward with interest to the OECD's ongoing work in this area. Thank you.
Thank you very much, Nathalie. And now, last but not least, I would like to invite Simon to tell us a little bit more about the US CPSC's advancements on ensuring the safety of IoT products. So Simon, the floor is yours.
Yes, thank you so much. I'm going to share screen, please. Again. Yes, can everyone can see that, please? Yeah, thank you so much for letting me share the and speak with everyone again. It's an honor, of course. You know, going all the great insights and presentations, going off what Natalie said from ACCC, we're very similar in that we're looking at cybersecurity incidents as a nexus. If a cybersecurity you know, has a second order effect and it causes a physical safety hazard, as I mentioned before. So it's a nexus. We called it before hazardization. It's a word folks have made up if it becomes you know, that physical safety hazard from that cybersecurity effect. And then the majority of our, you know, a lot of our partnership is recalls as well. Majority of our things that involve IoT is from those physical safety hazards. They just happen to be an IoT product, and it's not a direct result from, you know, what we're looking at this whole project from 2019, this nexus of cybersecurity. You know, their lithium-ion battery, you know, issues. There's electric shock issues and such. It just happens to be an IoT product. We've also seen the same thing, very similar to what Natalie said about a, you know, kind of jumping on, also like a Nest way back years ago. Nest had a wave feature, wave to silence. There's a recall on that. That was a partnership, what we call a fast track recall. We didn't really look at it in the lab, but just want to piggyback on a little bit what she said. It was such great information. Hopefully I can expand more on that too. But looking at on the slide, we want to talk about some of what we do. You know, data collection. I was briefly talking about before. We're a data-driven agency. We have a watch list where we put on all the different from all of our consumer data, our consumer reports. We call it CPSC 360, where we saferproducts.gov, where we collect all of our consumer data and consumer reports. And we've been analyzing that. We have a IoT product incident list. And so far we've had things like, you know, thermostats. We've had, you know, what we mentioned before, what Natalie's mentioned, you know, baby monitors. And then we were looking at, you know, what could be hacked into. We're looking at that nexus. What could be supposedly a cybersecurity incident or a hacking. Baby monitors, you know, all types of smart appliances. So part of that, also part of data collection, we also do a lot of collaboration because we're a relatively small agency compared to a lot of the other bigger regulatory agencies. So we're doing a lot of partnership with industry, a lot with NIST. You know, NIST is National Institutes of Standards and Technology. They're famous for the atomic clock in Colorado. And they're also, a lot of their work is cybersecurity. You know, they're the premier government agency for cybersecurity. That they've been tasked with a lot of our national United States executive orders for AI, ML, and also for the past cybersecurity work too. The Executive Order 14028 tasks them with many you know, different mission subtasks, and we've been partnering with them and monitoring a lot of their work. A lot of their work has been one of their specific projects. Here's one of their product documents. They put out various product documents. One of it is the NIST 8267. You know, they went specifically in the consumer home. That's what our jurisdiction is, the consumer home. Anything that touches a consumer, the smart home. They did an analysis project, a product document, You can see here the 8267. And actually, we had an interagency agreement with them where they had a lab demo where they went through a lot of the products that they demonstrated in the 8267, along with various product documents that they work on. You know, they also work on the 8259, which formed a lot of the baseline work for the cybersecurity labeling. That's something that's come out recently from the Biden administration. U.S. Cyber Trust Mark. So that's product document 8425, which is the profiles of that, how to apply that, the baseline work that they did from their 8259. Throwing out a lot of product document numbers, but so for their 8267, they went through these kind of products. They went through a smart thermostat or smart plug. And, you know, our direct mission is physical safety hazards always. So we want to, you know, cybersecurity is a huge field. It's a lot of activity now. But we only do for our jurisdiction, for our mission, for physical safety hazards. You know, some of their findings, and it's public knowledge of this product document. You know, there's weak encryption. Folks always mention, you know, default passwords, weak passwords, you know, firmware software update, whether that is tracked or not, whether or not the product does that. You know, because like Natalie mentioned, there's a lot of firmware software updates that fix products now. One of our concerns is, hey, could it be what we call like a silent recall, like a manufacturer goes through, does this firmware software update, and then somehow we miss that. But you know, that happens all the time, patches and such to fix different products. We've seen like a Verizon battery wireless transmitter. They, you know, just like Natalie mentioned, they send that patch and they regulate the battery level of that lithium-ion battery. We've seen that in various products. So some of these findings, you know, firmware can be installed, malicious firmware hacking, what we've been talking about before, malicious code could be installed through that weaker encryption. So this goes through more details of what they found. And then, so NIST did kind of a look at a network, and they formed a digital picture of that network. Because first we want to go and identify each piece of the network. So they demonstrated some open source tools where they could find, you know, like the firmware software version, where it is in the network, because everything on IoT products is always connected to a network. You know, it's connected to a router, it's connected to sometimes a hub, sometimes other, you know, just my home. I'm not a very savvy consumer user. I just have myself, I have a smart thermostat, I have a baby monitor, I have my laptops, I have my smartphones. So yeah, everything's a network, everything's, you have to consider which is the secondary piece of equipment, which is the primary. So you have to identify that if you can do that digitally or not. So to form that digital network. That's on the previous slide, which I skipped, but so there's some examples on what we partnered with NIST on what they trained us on. So we wanted to go even deeper. And now all these are programs that we're a part of that could form data for case studies. So we don't, not necessarily, you know, I touched upon some of our case studies that we've seen, but these are all programs that were ongoing that form, you know, assessment methods for possible case studies. I want to caveat that too. But now we had another industry partner expert on cybersecurity, reverse engineering, and they demonstrated it's ongoing task orders, multiple task orders. They demonstrated how they could go into the piece of equipment, into the IoT product itself through, you know, a lot of times there's a serial port, there's a JTAG. You could physically go on the device and connect to it. They demonstrated that method. They also demonstrated firmware software tools like common, you know, port scanners, common ways that you can see all the protocols going back and forth through the communication means. And they did, you know, physically connected. They physically connected, try to go into the firmware and step through it. You know, there's different types of ways you can test the firmware software. You know, there's malformed inputs. There's ways you can do buffer overflow. You can stress test it. So they went through those demonstrations with us. A lot of them were open source tools. You could do a network scanner, penetration testing. So they go through that really intricate technical analysis to see, you know, whether they could control the device or not and put it in an unsafe manner. And they actually found some findings currently. They had a smart coffee pot, you know, where they did a repeated denial of service attack, repeated commands, and they actually made it continue to brew. And then also listed all the products that we sent them. We thought that it could have more physical energy associated with, like a coffee pot, toaster, oven can burn, air fryers in the news now can burn. So we wanted to give them a list of products where they had the most potential for, physical, electrical energy, our fire hazards. So that's what that list is here at the top. So that's what continuing some of the industry expert partnership we're doing. So jumping on some of what Natalie said, that's the majority of my presentation. Thank you so much.
Thank you very much, Simon. This concludes our round of presentation. So now we'll go for the question and discussion part. Maybe I will open that part by asking a question to you. And in your presentation, you mentioned the collaboration with industry and all that, and this is definitely something that in Canada we see as very valuable. So I wanted to ask you, what industry-led initiatives you feel can augment the regulatory measures for emerging technologies?
Thanks, Sean Emmanuel. I think there are a few things here that are the more structured, traditional initiatives such as standards. So, of course, standards are industry-led. They may be adopted by governments, regulators, policyholders as sort of quasi legal documents. But they are industry-led, and so that is a key way, as you might imagine, I would say, working for the Office for Product Safety and Standards. Standards are a key way of industry almost self-regulating. That we are always happy to be invited onto standards committees and to talk to industry through that mechanism. And as I said, we adopt standards in our framework. We can adopt standards as being a proxy for the law. So they can act in a range of ways from soft to fairly hard compliance. I think there are other initiatives that could be much more bespoke and specific to certain areas of legislation in terms of bringing people together to discuss rather than to legislate or regulate. So Martin Allen, who's on the bill today, we have been on collaborating with his organisation and others on the PSTI bill, the telecommunications bill that I mentioned, that talks about governance of things like passwords, sequential passwords, easy to guess passwords. We've worked with the policyholder, Martin, others in industry, to talk with them about how we might regulate and what they might want to focus on, and understand their prime concerns and bring them back into the government side. So there are multiple mechanisms we can engage.
Thank you very much. Now I've got a question for Jisuk. This is something that we faced also in Canada, and I'd like to hear that from you in terms of how do you handle the responsibility when the safety responsibility is actually shared between different government agencies, and how did you, in your specific case, address that and sort that out?
Korean product safety regulatory authorities cooperate when there is a gap or different jurisdiction issues arises. So when there is a gap for consumer health or product safety issues, then Korean regulatory authorities get together and form a task force team or committee and cooperate with each other. So because my home agency, Korea Consumer Agency, is a regulatory authority which protects all consumers from all kinds of consumer products. So we often experience such issues, jurisdictions, and responsibility or sometimes there is a regulatory gap, then, for example, in my case, it was IoT security, which is covered by jurisdiction of Ministry of Science of Korea. So we often cooperate with many ministries, not only just Ministry of Science, but also with Korean FDA and Korean, of course, KFT, Korean FTC, something like that. So that's how we deal with such issues to protect consumer.
Thank you. Yeah, that's often very difficult to coordinate with all the various agencies, and it's a lot of work. Now I've got a question for Natalie. Wanted to know, you mentioned several times the software updates that you faced, etc. And I would like to know what kind of issues you're seeing in relation to software updates, the issue that could maybe be relevant to the way the regulatory regimes may need to adapt.
Thank you. Thanks for the question. Well, I mean, as we've seen, software updates are, in some respects, creating product safety risks and issues, but there's also that element of the positive perspective. So the benefits of a software update, and another panelist earlier in this workshop talked about that. The benefits of being able to actually directly reach an affected consumer and address the product safety issue. That is a challenge for us in relation to recalls and having people reach affected consumers and respond. And the other aspect that I think is interesting as we continue to develop future considerations is the point that Simon actually spoke about in terms of a silent recall, which I think is a good way to describe it. It's that risk and the issue of software updates potentially not being visible to regulators. Suppliers may not notify a regulator of a recall. And then if we don't have visibility of that, we have less of a picture as to what sort of issues are affecting particular products and how we best regulate. So I think that having a better understanding of those emerging issues and how we might respond to those, or whether it's a matter of raising awareness about what we're seeing in this space and what we expect in terms of notification of a recall, are some of the considerations there. Thanks.
Thank you very much. Simon, you mentioned during your presentation the cyber trust mark. And I wanted to know a bit more about that and the how you could develop and give information that could be interested on the topic to the workshop.
Yeah, absolutely. Thanks for the question. You know, I mentioned before, partnering with NIST. They did a lot of the work necessary to develop that, and they're still using a lot of that, those product documents, the 8259 I mentioned before, the 8425 I think is the profiles to actually apply that. And now it rolled up, Biden administration, US announced that FCC, Federal Communications Commission, will be leading that, and they're actually they released a notice for public comment, notice of public rulemaking comment for that. If you read through that document, I can send that. Has some interesting things that they're open to. They're still open to actually who can be the actual scheme owner, who can really manage it. They're assigned to be they took over to be the overall managerial role, but they're looking for like a more kind of like a possibly third party, more of a technical manager. Another thing that jumped out was should manufacturers, or should the products that have the labels, should they be required to put how long they'll be supported for firmware software update? And that would be that's an interesting issue. That someone could see that on the label, because that's important. Everything, as a lot of the panelists have been mentioning, firmware software updates fix, or their patches, they fix a lot of issues. That's what they choose to do. The manufacturers should do, send it out there. So should that be, it's open for comment now. Should that be part of the label? How long should they support it? Because some manufacturers may not only support it, they're not indefinitely, definitely, maybe a year, 2 years, 10 years, something. When we work on smoke alarms, it's required to be like a 10-year requirement, 10-year, change the battery, 10-year lifetime. Should the same thing happen for IoT and connected products for the firmware software patches? Yeah, thank you so much.
Thank you very much, Simon. Now I have a question for I'm going to ask to the four of you and basically answer who wants. But we've heard in the previous panel talking about agility and reactivity and how things are moving fast, and I mean regulators are not sometimes the fastest of the group. So I wanted to hear from you and from your experience. Are there any existing tools, processes, and enforcement, policy and enforcement regimes that do you think that they are appropriate, and do you think that there would be some needs for them to be adapted fast? Anyone? Whoa, I asked you a big question. Okay,
Sorry, I just took myself off mute. I was just, one thing that I was going to say to that, and there will be others who may want to add, is just, I think the pace at which some of these issues arise and change definitely makes it challenging to respond to the issues if the change requires regulatory change. However, in the meantime, the opportunity to work collaboratively with other regulators, including internationally, is of benefit to really understand the issues that people are seeing across their jurisdictions, and finding ways in which we can adapt and respond quickly. So I think that that's one way that we can help to mitigate that risk, but others may have other views on that. Thanks.
Thank you, Natalie. Any other reaction to Yuan? Do you want to intervene?
Yeah, I agree with what Natalie said. I think also it's important as regulators to understand the potential risks, the issues, and the challenges before acting. And I think what we are seeing in the UK on products is that they will claim to use new technology as a way to attract consumers, but actually when we investigate, they don't necessarily use AI, they don't use machine learning to the extent that they claim to. And so we need to do these investigations before we jump in, I think. So to add some balance, yes, potentially we could act more quickly and use sort of global links like today, but also we need to understand the problem.
Yeah, that's very true. So that brings us to the end of the session. So thank you very much to the four of you for participating. I think that it's been a great opportunity for the various regulators, including Health Canada, to kind of learn of your own experience and see how things have been dealt with. And I really look forward to continuing the collaborative work within the OECD and the project on new digital technology over the next 2 years and beyond. So now let me pass the floor to Wendy Middleton, who will moderate the next and final session of today's workshop. Wendy, the floor is yours. Thank you very much.
Thank you so much, and hello and good afternoon, everyone. My name's Wendy Middleton. I'm the Deputy Director for Science and Engineering in the Office for Product Safety and Standards, and you've heard from a number of my colleagues throughout the day. I'm your moderator for this final session of our workshop. Firstly, congratulations, well done. You've made it this far. This is now the last session of what's been an excellent day, I'm sure you'll agree, of presentations and discussions. So you can hang in there now. You're on the home run. This is going to be the last session of the day, and I promise we shall reward you with a very rich and stimulating discussion. So throughout the day, we've enjoyed a variety of different sessions, providing first, we looked at insights on specific health and safety risks associated with digital technology products. We then talked a little bit about the tools that are being used to identify and assess those risks before working through various case studies in that last session, illustrating how product safety regulations are trying to sort of come to grapple with those issues. In this final session, we'll be providing an outlook on emerging issues relating to the future of digital products from the perspective of different stakeholders in this space. So we're going to step away a little bit from the digital technology products we know about today and transport our minds a bit into the future to think more broadly about emerging technology and future technologies, particularly AI, and what kind of implications we should be aware of to ensure that we're continuing to safeguard consumer health and safety. So to help with this discussion then, I'm absolutely thrilled to have with us today Jill Crisman. She's the Executive Director of the Digital Safety Research Institute, which is part of the UL Research Institutes. Rod Freeman, he's a partner at Cooley LLC. Nicholas Miliani, the co-founder and CEO of Prism Evaluation and the founder and chairman of the board of the Future Society. And David Sedek, the Vice President for the Research, Technology and Innovation at Thales, and he's in charge of artificial intelligence and information processing. Now, for those who've spent the whole day with us, you kind of know the deal by now. I'm first going to invite each panelist to provide a presentation, and then we'll open up the floor for more general questions and answers. And please, can I encourage all of you to pop those into the chat as we go along, and we'll draw from those at the end. So without further ado, Rod, can I start with you? Could you please provide us with your perspective from a law firm with a big focus on product compliance on the key trends you're seeing, pointing to how technologies could raise challenges for product safety regulation, policy and enforcement going forwards?
Yes, and thanks very much, Wendy. And just to echo what you've said, it's been a really stimulating session so far. And what I'd like to do to kick off this final session is to perhaps sort of draw some of the themes together that we've heard during the course of the presentations today, and to think about where this takes us and where we're headed in terms of regulatory policy and compliance in the area of new digital technologies. Now, one of the sort of fundamental themes that brings us here, really, I think, is that new technologies do challenge some of the traditional concepts that underpin existing regulatory and product safety policy. History has shown us that existing regimes are actually pretty resilient and pretty flexible when it comes to dealing with changes in technologies, but there is something about new digital technologies that makes it different and gives rise to this need for a rethink about approaches to regulation and about some specific issues that new digital technologies give rise to. It's questions like, back to the fundamentals, what is a product? And in some ways, that's not a difficult question. The question is software a product? Is really at the heart of this, and that's not a difficult question. But the answer is certainly very difficult, and we still don't really have a coherent answer or a consensus answer to that question as to whether, not so much whether software can be a product, but in what circumstances is software something that should be regulated under a product safety structure. So we're still grappling with that, and we need to get a proper grip on that. Something we haven't heard a lot about today, but looms large, is the question of who is actually responsible. So it's important to identify the standards that we need to put in place, the structures to define what safe digital technologies are, but we also need to work out how are we going to allocate responsibility in a world where regulations work on the basis that responsibilities are allocated and people are held accountable. We need to often grapple with that when we're talking about connected products, artificial intelligence, 3D printing, identifying who is the party that needs to carry the can if something goes wrong, or frankly needs to carry the can in terms of ensuring that technology is safe before it goes to market. And then we have the fundamental question of what do we mean by safety? Yeah, we've heard some talk today about psychological harm and mental health. There's issues around data security and privacy, which has also been touched on today. And of course, we're in a world where there's a lot of focus on sustainability and environmental safety. So when we talk about product safety, we need to be clear about what we mean. And that takes me on to my second theme, and that is that the new digital technologies do bring challenges for policy and enforcement. There was a question about this in the last session, actually. That what we are dealing with is an area where there are different areas of policy that come into play. So we're approaching this from the point of view of product safety. But a lot of what we're talking about also is around data security that has very substantial overlap with privacy. And privacy, of course, is a policy area in its own right. In many ways, is more advanced than product safety policy in this area for some sort of fairly obvious reasons. So working out where the sort of demarcation is, where does sort of one area of policy start and stop, or how do we manage the overlap, is a very important question. And then there's another policy area, which is an emerging one around online harms. So when we start to think about psychological injury, then we're very firmly in that area as well. Issues around privacy, issues around cyberbullying, inappropriate content, inciting violence, those kinds of issues are safety issues. But I think for the most part, we think of that as a different policy area to what we're dealing with here. So it's a challenge when it comes to developing policy, because we need coherence. We can't have competing policies in this area that are not going to work together. But it also is very real in terms of enforcement, and this is sort of where it really becomes real. And again, this was touched on in the last session. How do we manage it in circumstances where different regulators effectively potentially have the responsibility? And whilst one solution is sort of reassurance that government departments talk to each other and sort things out when problems arise, to my mind, that misses the point slightly, because what we're talking about is something that's going to become the norm, that this clash of policy is not going to be an exceptional situation, it's going to become the norm from an enforcement point of view. So I think we really need to work that out. And then my final theme that I wanted to touch on before handing over to the other speakers is just to reflect on the pace of change. That technology, as we know, is moving fast. Again, one of the reasons we're here talking about this is because technology moves fast, and regulation tends to be playing catch up. Now that's a normal dynamic, that regulation typically follows technology rather than leads technology. But when it comes to new digital technologies, it's the pace of change that is causing the problems. And I think we need to accept that reality, because that's not going to stop. That we're at a sort of inflection point now, I feel, with the development of regulation in this area. But we need to anticipate that change is going to continue, and change is going to happen fast. And certainly it's going to happen faster than regulation can. And that's why I think it's really important to also sort of look at other ways to manage safety in this area, rather than exclusively relying upon regulation. And we've heard some really helpful references to that during the sessions today around collaboration, industry-led guidelines. I think the product safety pledges that are in place in Europe and now in other parts of the world are an excellent example of how voluntary measures and collaboration with industry can produce quick and fast and effective solutions in circumstances where regulation is going to be playing catch up. So those things I think are very important as we think about moving forward. So on that note, I'll hand back to Wendy, and look forward to hearing what we've got from our other speakers.
Thank you so much, Rod. That's really interesting, really helpful, and particularly enjoyed your sort of exploration of different sort of modes of regulation. Regulation isn't necessarily just about legislation, thinking about a broader toolkit as to how we're going to sort of rise to these emerging challenges. So thank you, Rod. I'd now like to turn to David. Hi, David. I understand Thales has been thinking about AI in a broad sense, and the kinds of principles that need to be abided by to ensure its trustworthiness. And I know we've sort of touched on this throughout the day's sessions. Would you be able to perhaps elaborate on this a little bit from your perspective?
Thank you, Wendy. Can you hear me? Is it okay? Okay, thank you. So yeah, thanks a lot for having me with you today. So I'm very, very happy to share with you what we've been doing at Thales with respect to digital technologies and especially on AI. As you know, probably Thales is a business-to-business company or business-to-government company, but nevertheless, behind the second B or the G, there is an end user, so there is a consumer, and the Thales business actually ranges over a very wide spectrum, going from aeronautics to digital identity and security, and it includes well. It comes within very regulated domains, which are critical domains, domains where human life can be at stake, where financial transaction can be at stake, where defense mission can be at stake. And this is why we have completely designed our AI strategy along the lines of trustworthy AI for critical systems. And this approach actually relies on 4 pillars for us. I don't know if I can share my slide. I have some slides to share. Let me just try if I can do this. It looks like to be a little bit difficult. Otherwise, I can just do it a cappella. Okay, no, let me just continue without showing anything. These 4 pillars are validity of these systems, which is the basis of safety, security of the systems, explainability, and responsibility. Let me just say a few words about each of these pillars. So the validity of the systems is the guarantee that an AI-based system will do what is meant to do, all what is meant to do, and only what is meant to do, no more, no less. And of course, when you are dealing with critical systems, it's really a crucial issue here. When Netflix recommends you a movie you don't like, so it's not a big deal. So you just pick up another one, and that's it. Now, if you are taking a flight, provided that two aircrafts out of 3 in the world take off or land thanks to Thales systems. So if these systems involve digital technology, so it's better you can trust these systems, and because it's a matter of your safety, of the passenger safety. And when you are using a system which does border control, for example, to control your passport, so if the system makes a mistake in identifying someone as being someone else, a terrorist or someone who is looked for, so it could have very heavy consequences, psychological, physical consequences on citizens. So this is the validity is an essential pillar of trustworthy AI for critical systems. The second pillar is security. Security is the assurance that of robustness and resilience to any kind of malevolent behavior, and especially to cyber attacks. So we have in Thales a team which does friendly hacking, kind of friendly hacking to test the resilience of the AI-based systems to any kind of decoying, for example, any kind of cyber attacks, and to propose countermeasures to make these systems robust enough to this kind of behaviors. Explainability is also the ability to justify, to provide to the consumer the reasons for which an AI-based systems did what it did or recommended to do what it recommended to do. I mean, even if you have a product you are using, in some cases you want to ask the question, why should I do that, and why are you recommending to me to do this? I mean, we face this situation even with our own GPS every day when your Google Maps or Wise recommends you to take some way. So you want to ask, why should I do that? Especially if you have a questioning about what the system is recommending, for example. And finally, responsibility is the guarantee that the systems are compliant with ethical regulatory framework, with legal framework. And along this pillar, you find the balance of the data sets, for example, which are used to train AI systems. You find also the privacy of the data which is used, for example. You find also the respect of environment and the carbon footprint, for example, and energy, the use of the energy by the systems based on AI technologies. And within this framework, we have also established an ethical charter, which consists in 10 commitments, and these commitments are clustered in 3 groups: for a safer world, for a greener world, and for a more inclusive world. And each of these commitments is about also reducing and mitigating the risks that the users, the final users, the end users, sorry, have in using digital technologies, and especially AI-based systems, such as the ability for the human being to have the control of the AI system at any time, for example, or the ability also, as I mentioned before, that an AI-based system can explain, justify its behavior when needed. So all what we have been doing so far is about safety, security, and responsibility of the systems which are used by consumers, and more generally by citizens, I would say. This is as an introduction of what I wanted to say, so I would be happy to hear also from my colleagues.
That's great. Thank you so much, David. There was so much in that, and I think obviously we'll have questions at the end, but useful to explore sort of more with you in terms of what we should be doing in that space now. And I'm thinking particularly in terms of things like near miss reporting, failure error reporting, and sort of the transparency of how companies are doing that and dealing with the consequences of that, and what that means for setting the foundations for the future. But we'll come to questions shortly. Now, can I please give the floor to Nicholas, whose organisations, the Future Society and Prism Eval, in a similar vein, to seek to help to develop safe frameworks, principles and mechanisms for safe AI. Nicholas, hi. Could you please elaborate a bit more on those in the context of possible future AI-based consumer products and how we should be addressing their health and safety risks?
Right. Thanks a lot, Wendy. Good morning, everyone from San Francisco. Can you hear me properly? Am I audible? Okay, that's great. Would you mind bringing up the slides, production team? And by the way, thank you so much for organizing and coordinating all these important matters. And I'll get started while you bring up the slides. There will be a few. I think it's useful to have these visual supporting pieces, because the artifact that we have to govern moving forward and the kind of challenges that we have to confront in terms of ensuring safety at the consumer level, at a group level, at society's level, and even more systemic type of risks, including, according to some, risks to humanity and risks to the survival of humanity, which I certainly don't think we should brush under the carpet. We should not miscalibrate them. We should not overinflate them, but we should consider them for what they are. When we are at a point, according to some, at OpenAI, at Anthropic AI, at DeepMind, who believe that we are getting close to general purpose AI systems, which are capable of at least simulating common sense capabilities that are receiving an immense pressure from consumer to be deployed. You can move to the next slide. Thank you so much. The one before. Thank you so much. The one with the black box. Yes, thank you. When we're seeing such a pressure to deploy these increasingly powerful AI systems, and we've seen, you probably, as I do, use every day, there's GPTs of the world, these generative pre-trained transformer models, which is the underlying techno-scientific apparatus and cocktail that we have in front of us. The pressure to deploy with hundreds of millions of users every day is immense. The fact of the matter that no one denies, and I think that David painted a picture of what we, humanity, have been able to invent in terms of ensuring safety at the industrial level when we decide to position these advanced systems within what we call safety critical functions, mission critical functions, to fly airplanes, to build bridges, to build skyscrapers, all these infrastructure related safety critical missions, and the types of practices that we have developed, that humans have developed over the past centuries to ensure the safety of those, such as testing, evaluating, verifying, and validating, and qualifying, and certifying, is something that we have, I'm sorry to put it that way, we have so far no capacity to deliver over the underlying techno-scientific cocktail that we have in front of us. Why? Because if you look at the size and the magnitude of an artifact like GPT-4, the number of parameters have not been disclosed, but we can assume that it's over 1 trillion parameters with several trillions of data points used to train it. We have in front of us, at the center of our managerial table, at our consumer and systemic risk table, immense black box AIs. In other words, systems of which not even the designers understand how to interpret their reactions and how to ensure their robustness. So we have an immense robustness and evaluation problem to deal with, and we have not the ability to respond at the level, at the velocity that is needed to confront the pressure to deploy coming from our consumers who desire to embark these models into agents and to transform these agents and incorporate these agents into applications in different places in the economy. That too, at the moment where the value chain, the underlying value chain, is not as structured, is not as established as the value chain that we have, for example, in aerospace. You know, when an aircraft takes off, pretty much everything within the aircraft is regulated. When we switch in our homes, electricity on or off, pretty much everything within the value chain is regulated in one way or another. And so if we are going to move AI at the center of more and more functions, especially critical functions, we have to think in terms of what we need to regulate and how, because a lot of these other infrastructure, so-called general purpose technologies are in fact regulated. And here, do we understand electricity? Do we understand thermodynamics? We do. The science of AI is not understood, and we have, I'm sorry to say, no immediate pathway to transform the black box into a white box. That's the problem. That's the question. Next slide, please. And according to some, as I said, this idea, these large language models, which are becoming multimodal, are simply stochastic parrots, repeating what we say, according to some in the community. And I'm in San Francisco today because in San Francisco, though I'm based in Paris, there are a lot of these labs. And all my peers trying to do AI evaluation are located there, trying, for example, to address these questions. Is the next best word prediction, that is the key algorithmic function driving these large language models, do they, beyond the ability to simply predict the next best word in a sentence, do they exhibit a deeper understanding because of the sheer magnitude of the size of the model and the ability to fuel it with so many data points? We're talking in trillions these days. So that's why we have this joke here. Is it these days? I repeat, therefore I am. Because if it is the case, we have in front of us more powerful technical artifacts. I'm not even talking about consciousness, we're just simply looking at what they're capable of simulating. But if they are capable of simulating reasoning and planning, but we have no capability to have a good interpretability of how they operate, not even explainability, then we have a big problem. How do we deal with that? Is what we have to do collectively, and what Prismeval and many other organizations are about, because this field is burgeoning. Next slide, please. What do we mean by safety evaluation? Because a lot of what was decided at Bletchley Park with this AI Safety Summit was to create the conditions for these powerful models to be evaluated before they are deployed. What we have in front of us in the short term and in the next couple of years are multiple cases of misuses. What we have potentially ahead of us, because of this moving beyond the stochastic parrot hypothesis, potentially loss of control, especially if we start deploying these systems at the center of our economies, at the center of our critical functions, because they deliver immense productivity gains potentially. And underlying this trajectory, this historic arc in the coming year, as I said, we have deep, fundamental, I will say, challenges of interpretability. We have a deeper miscomprehension of the models that we need to be able to solve. Next slide, please. To be a bit more like practical in terms of what we have in front of us, and we know that there's an election year going on in the US. You've all heard about, and in the UK as well, and in India as well, and in many other countries. We've all heard about the deepfakes. So disinformation campaigns, scamming, hacking, designing potentially viruses is something that is a problem in terms of the potential underlying capability of these models and the way in which they're steered by malintentioned actors and users. We have also to be able to evaluate the willingness and to understand the willingness of these systems. What is the willingness of the next best word prediction to say something which is racist, to say something which is sexist, to decide to sell a car on an e-commerce platform for only $1 on behalf of a customer that doesn't want that, and many other things. So we have to ensure the robustness at so many different levels, and right now we don't have the solution. So that's the challenge. Next slide, please. As I said, in London in November, at the level of heads of state, people congregated to realize and to acknowledge that immense challenge. And what they converged around at the Bletchley Park Declaration is the need to create this science of evaluation of these large language models and to create the conditions of public control of this process of robustification. There was announced the creation of the UK AI Safety Institute and the creation of a US AI Safety Institute that will be precisely tasked with research and development of evaluation methodologies to deal with questions of safety at the micro level, meaning consumer, but also at the macro level, systemic risks. And the way in which the EU AI Act has been finalized vis-à-vis its rules to govern foundation models is centered and is gravitating around this very notion of systemic risks. And so what I hope will happen in the future is that many countries are going to develop similar institutions, and the EU will do its AI office. France will start its AI Safety Institute. Japan will start one, Korea will start one, China will start one, India will start one, and they will be able to come together into a network to collaborate, and in that network relate with the other safety regulators dealing with consumer safety, for example. So I hope that we meet again in 1 year and we have a similar conversation where, ladies and gentlemen, we have colleagues from AI Safety Institutes discussing the emerging science of evaluation, because right now this science does not exist. We do not have metrology. And maybe we'll end with that, with my next and final slide. We need a science of evals. And this notion of the science of eval has been coined by some of my colleagues at Apollo Research, which is another amazing evaluation organization. In the world of industry, if you speak to NIST, if you ask this, what is the science of eval? They have a term for that. We, the humans, have invented something really solid for that. We call this metrology. Metrology is the science of measurement. And at the core of how we run industrial functions, there is the ability to measure with high granularity and high confidence what's happening at the center of a phenomena, of a physical or socio-technical phenomena. And this is where we need to go. Right now, the field of evals is just nascent. We don't have common terminology. What do we mean by auditing an algorithm versus adversarially robustness testing the algorithm? What do you mean by safety exactly? So we have no standards. We have no established value chain. We have no protocol to certify and mandate an AI safety evaluation by the regulator. all of that needs to come and needs to come quickly. In other words, we collectively have upon us to accelerate the pathway to move from nations to mature to maturation phase to a mature field and have standards and norms. We have the chance of having this EU Act that hopefully will serve as a forcing function to advance that. We have amazing efforts, for example, at NIST, US Safety Institute, to establish consortiums of actors to accelerate that. But let me tell you, it's going to be a challenge because meanwhile, the labs continue to develop these immense black boxes. GPT-5 is upon us in a couple of months or years, we don't know. And we can assume it's going to be more complex and more capable than GPT-4. So we are racing after the artifact we have to govern in the context of some would say a reckless race to the safety bottom. Others would say a race to innovation. I think they come together. And so balancing out safety and innovation at a consumer and systemic risk level is, I would end there, a challenge of a generation.
Thank you so much, Nicholas. I think that's really powerful, particularly your last sentiment there. And I think lots that we'll want to explore in the discussion at the end of this session. Thank you. So I'm now going to move on to our final speaker. Last but by absolutely no means least, Jill, let's finish with you. I understand the Digital Safety Research Institute at UL aims to protect individuals from rapidly evolving digital threats, including AI. And I know this is something you've been thinking about a lot, and we've obviously throughout the day been speaking a lot about AI threats. But what light can you offer us in terms of how we can develop new governance and oversight processes that might help us manage some of these hazards, some of these risks, and perhaps help us realise the real sort of potential opportunities these could offer us? Look forward to you elaborating on that. Jill, to you.
Yes, well, thank you very much. I'm thrilled to be here. This is my first time interacting with this group, so I thought I would at least give a brief introduction to myself. I'm going to focus on AI because I've actually been a researcher and engineer in AI for my entire career. I started in academia as a researcher. I was then in industry. I did advanced AI-enabled systems as an engineer. And then I was in government. I actually sponsored engineering or AI research for advanced systems. And I was also evaluating AI-enabled systems and actually setting policies for AI procurement. So I have a broad career. I joined UL Research Institutes because, you know, they have a long history in electrical system safety. And Andrew Ng, who is a global recognized leader in AI, claims that AI is a new electricity. And it's going to transform the world as much as electricity has transformed the world in the early 1900s. And UL began with the introduction of electricity at the World's Fair, trying to actually solve the problem for buildings catching on fire. And since then have been very instrumental in safety science, in safety standards for electricity, and has moved beyond that, is now doing a lot of testing and testing for safety of all kinds of products, as well as continuing to build standards and doing research. And I am, of course, part of the research institutes. And so I'm actually hoping as part of the director of the Digital Safety Research Science Institute that I'm going to bring safety to AI like UL has historically brought it to electricity. So when we talk about AI and the future, there's still a lot of debate over whether AI is an existential threat. And given the theme of this conference, I thought maybe I'd focus on actual physical harms that have been caused by AI even now. And I picked out two examples. One is a genocide that happened in Myanmar against the Rohingya that Facebook actually apologized some for. The UK government, UK and the US government accused them of not failing to provide local moderation, having algorithms that amplified hate speech against the Rohingya people, and didn't shut down accounts or delete groups and pages that were encouraging ethnic violence. So here is a current, and people will argue whether this is an AI system or not, but it's still a software system that has had massive physical harm effects on populations. In the second example I want to talk about that happened just last year, researchers at the Collaborations Pharmaceuticals, which is a company that actually looks for new drug candidates for rare and communicable diseases, were asked to make a presentation at an international conference on chemical and biological weapons. And so they started exploring with their AI model and actually found that if they did just one switch in the optimization criteria, that within 5 hours, it came up with over 40,000 new possible chemical weapons. And this was done on fairly small machines as well. And so if you think about what could happen with this as we go into the future, and so if you look at like the history of sort of software and, and AI as part of in the software space, it started with devices with firmware and sort of they were not connected to the internet. We sort of kind of know how to regulate those. But then devices connected to the internet and these software platforms with updates every 2 weeks. We've been talking about the pace of AI. Well, software actually has a faster pace than even the regulatory standards we have. And now we're moving to AI models that are trained with machine learning. And this is interesting because at this point in time, we have humans actually in the loop that are making sure these systems are actually learning what they hope they are going to learn. But a lot of the future, and I think where a lot of these existential threats are coming from, is what happens when AI is learning on its own and deployed autonomously. And so there's no humans in the loop watching what it's doing. And I think that's where a lot of the future existential threats are coming from. And we don't even have to go further. Even if I move out of the physical space, we've talked today about how physical harms and mental harms are actually interrelated to each other. But even looking at these other spaces and thinking what might happen, we've got deep fakes of, say, President Biden that just recently happened. They used his voice to try to convince, and a robocall system to convince voters to stay at home during the primaries just recently. We've also got scams that basically creates crypto drainers that actually go in and drain people's crypto accounts. We've got threat actors that are using AI to overcome security measures and interfere with elections. And we also have AI-generated explicit content that's being generated without users' consent. And if you start thinking about what happens if AI starts learning how to do these very bad behaviors on its own, we have some big dangers here. But I really want to emphasize this development of software from, first we had firmware, and now we have software connected to the internet, and then sort of AI, and then we have generative AI, and then, potentially future AI. I think the way that we should be looking at solving these threats and evolving future threats are looking at sort of what we're doing now, making sure we're fixing what's happening there, and looking to the future. So I'm focusing on the NIST risk management framework. PRISM is actually very interesting, which I've learned about today. Would love to talk about that. But if you think about what the risk management frameworks are, they're sort of categorizing your systems and what the risks are, selecting the controls and making sure they're all implemented, authorizing systems that meet these controls, and then monitoring those systems. And these things get integrated into automation that in a DevSecOps chain that allows people to actually update the software very rapidly. And so now, a lot of the new AI things that are coming out are looking at, okay, what kinds of controls do we actually need in addition to the cybersecurity controls that we tend to have in just the risk management framework. And that includes, safe, secure and resilient, explainable, interpretable, privacy enhanced, fair with harmful bias managed, accountable, transparency, valid and reliable. And I've heard several versions of this today, and a lot of frameworks cover these same things. But I want to look at sort of, in addition to this, we need sort of oversight. So in these critically harmful systems, how do we actually get oversight into this? So so outside auditors can actually look at what these systems are doing. The other thing we might want to add is measures of public safety. And I like to think of this in terms of public insurability. So one of the best ways a company could basically build trust in their products is to actually insure it against harms, against consumer harms and potentially against public harms. So we like to think about what could we integrate sort of insurability measures into some of these things to look at public safety. And then we need automated controls to keep up with the pace of the digital ecosystem. So if the systems are evolving and deploying every week, and as we move, every 2 weeks for software, and we move into maybe daily with AI, with people in the loop, and now we're going to move with automated AI updating constantly, how are we going to get in the loop to actually monitor these things? And this is sort of what I'm imagining. I'm imagining a dynamic AI digital governance ecosystem. So we need to sort of build a new ecosystem that has digital labeling for public safety and societal safety, but it's got to be as agile and as dynamic as the systems that are themselves. And so, it starts with incident monitoring, and we heard about AIM today, but actually monitoring systems, monitoring harms as they're coming out. So we need to have these advocate organizations like EEOTC. We're actually working on the Digital Safety Research Institute is also helping with the software development of the AI incident database. And these things all need to be aggregated together so we have a good scan of what exactly the harms are coming from these systems at the public level. And then what I would really love to see is standards written as code. And yes, we need to have the documents that describe them, but instead of writing standards as a document, which then has to be later interpreted and implemented, let's do that all at once. Let's create what we want as labeling that actually labels public safety. And then let's actually sit down with policymakers, with users, with citizens, with engineers, and let's try building these safety measures as we go that actually measures our policy. And so I'm showing there just, the standard safety label for privacy that's given out. I think this was the Apple one, but we need to have that kind of labeling, but done for public safety for these systems and automatically generate code that actually measures this stuff. Once you have that code, it could be easily slipped into DevSecOps or machine learning platforms that are automatically scanning and deploying machine learning. So let's put that in and let's get these measurements actually so that an AI model providers could actually provide us exactly those societal safety measures that we need. And that could, and all AI is wrapped in software. So let's go put that in the DevSecOps. So let's create a data, machine learning, development and deployment and operational cycle and get these measures actually deployed in there, get the labeling coming out with each new iteration of the product. And then of course we need auditing interfaces for oversight, especially for critical systems. So this is my vision of the future. I think we all need to work together to get there because you can see there's roles for all kinds of people, but we need to make it as dynamic as these systems are themselves. And so my last slide is if you kind of like this idea of a dynamic system and creating everything at once, here's my contact information. I would love to talk to folks who are interested in these kinds of ideas and partnering.
Thank you, Jill. Thanks so much. Also for offering us some hope in terms of your vision for what a sort of a sustainable ecosystem could be to manage some of these sort of emerging threats, if you like. Thank you for sharing that. And I'm sure folks will want to get in touch with you to discuss further. We've got sort of 5-7 minutes or so for some questions. So if folk would like to answer any questions, please can I encourage you to pop those into the Q&A now. Otherwise, I've got a couple of questions for the panelists just to kick us off. I think, Nicholas, sort of going back to your presentation, you rightly reflected on the pace of technological change. It's moving so fast, and things that felt like they were just around the corner, general purpose AI or AGI, are very much sort of feel quite here and now. If we're trying to sort of think to the future, if they're in front of us now, then what on earth's next? What's next on the horizon, would you predict?
Thanks a lot. Number one, I would like to wholeheartedly support the framework that Jill has put on the table. I think it's an excellent way to think practically about how we go about that. So think about that framework as the underlying piece that we have to build together. What lies upon us as AI is being wrapped into software and software functions, which we call in my world scaffoldings to build models into agents. What on the horizon is brain-computer interface, BCI. So the way in which humans and machines are going to increasingly collaborate is not only by delegating more and more autonomous functions to advanced models, which is a matter of big preoccupation, Jill is absolutely right, is also the way in which we are going to collaborate because the systems are powerful. How are we going to basically hook our biological brains with and to these models This is going to be done to an emerging field. You've heard about Neuralink, for example. And so the way in which we are going to connect our brains with these models creates a degree of intensity in terms of all the challenges we've been discussing today. The robustness, privacy, to which I would add free will. What does free will becomes when it is the product of a very fast-paced feedback loop between semiconductors and our biological brains, that too in a wide socio-technical system, namely society? How do we ensure that the tenets of our fundamental rights of our liberal and democratic societies are ensured is something that is clearly now, in my opinion, on the horizon because of the accelerated pace of the move towards AI and the move towards brain-computer interfaces. Thank you.
Thank you so much for that. Obviously, we're very lucky you're here and we're able to ask an expert such as yourself that kind of question on the panel. But Rod, I'm wondering, how do the companies you engage with, how can they hope to sort of stay on top of all of these developing technologies? How do they access sort of the expertise of folk like Nicholas? What's the advice you're giving to them and indeed us as regulators?
Yes, well, I mean, it is a challenge, and I think part of the answer is to recognise the challenge. I mean, certainly, I think all of us in this area realise we're in a moment of history where there's an unprecedented level of regulatory change around the world, and much of that change is being driven by concerns about new digital technologies and whether existing systems and regimes are fit for purpose. So we have that challenge that we all need to grapple with. Frankly, for most companies, it is a question of trying to find ways to tap into as many resources as possible, because there's no sort of single source of knowledge in this area as regulations are changing around the world, unfortunately. And then with the work of OECD is an excellent example of a resource that's really, really valuable, because it is a place where a lot of the thinking is brought together, not just in terms of what's going on right now, but also through also insight into what's happening in the future. So sort of tapping in through business at OECD is sort of one way to try to get some sort of grip on what's going on around the world. But there's no easy solution to this. Perhaps in the not so distant future, AI will produce a solution to how to keep track of regulatory change around the world. I'm sure it will, but we're not quite there yet.
Thank you, Rod. Nice circular argument there as well. And then I think probably got time for one more. I'm going to put this to both, I think, David and Jill, because you probably both got slightly different perspectives on it. David, I mentioned, you spoke briefly about the importance of incident reporting, and I know Jill explicitly spoke about that in her ecosystem. I'm really interested in your thoughts in terms of what sort of open incident reporting means in terms of trustworthiness, and how can we hope to engage with those creating technologies to create a culture where people feel that it is safe to report on near misses, on incidents. Just interested in your thoughts on that. You're on mute.
Yes. Yeah. Okay. Thank you, Andy, for the question. So I would say that the trust is gained by drop and lost by bucket, actually. So you can, if you want to bring people to trust AI systems or digital systems, so it's somehow a long way to make people really rely on these systems without any kind of fear, for example. For systems which are already regulated, as mentioned by Nicholas earlier, as aeronautics, for example, things are now really processed. You cannot embark any component in aircraft, for example, or software or hardware component, if the component doesn't comply with a very high safety level, very high safety criteria. Now, speaking of, for example, generative AI, we talked about ChatGPT and other systems. Things are really under experimentation now. So, and an AI Act, for example, the European AI Act, which is intending to regulate the use of AI systems on the basis of a risk analysis, require, nevertheless, many definitions and many specifications to understand what is meant by explainability, for example, what is meant by safety, even safety in some cases. And this is why standardizing, for example, AI attributes or safety attributes or trust attributes is really essential here. So in France, we have a program which is called Confiance.ai, which is intended to define this kind of attributes for trust, for example, and to put this within standards is really a key step toward trustworthy AI, especially for critical systems. And qualification of these systems is per se, has to be defined per se. It's not clear now what does it mean to qualify an AI system and even to certify an AI system, especially if the AI system is doing what's called the continuous learning, which means that the system continues to learn when it is used. So even if you have proven very valid properties on the system, when you deploy it, you have to prove that the system will keep these good properties further when it continues learning, for example. So this is one of the points. I don't want to speak more because I know that we are running out of time. But this
Oh, no. Thank you, David. I think that's always the challenge, isn't there? We open so many boxes. There's so much great opportunity for discussion. Jill, I wanted to pass to you, but with regret, we're already a little bit over time. So I might ask you to pop your response in the chat, if I may, in terms of how we think about incident reporting. Because yes, with regret, we are now at time for this session. So can I thank you all for your engagement, your questions, and this really interesting discussion we've just had. This brings us to the end. Let me just take this opportunity to thank all of our panelists just for their excellent contributions. It's been a real privilege to have you with us today. I'm now going to pass the floor back to Will Creswell to close this workshop with some concluding remarks. Thank you.
Thank you.
Thanks, Wendy. Can you see me? I hope you can. Good. Thank you, Wendy. What a lively and informative set of discussions we've had today. Really fantastic. But it just goes to show what an enormous subject we're talking about. So we've heard a wide range of perspectives from government, business, consumer organizations, technical specialists, academia, and other experts. And just to recap all that briefly, if I may, we heard about the evolving digital technology product landscape. A key takeaway was that the sheer number of new technology products that have emerged in recent years, and the need for all stakeholders to be aware of the risks, but also the opportunities. Some panelists considered consumers are less safe today than they were 20 years ago. And that's due to the risks that are not yet adequately addressed by existing rules, while others pointed to examples where AI is leading to improved consumer safety outcomes, such as improved product recalls. We also heard about some key product safety issues raised by specific new digital technologies, namely AI, IoT, and VR, as well as related policy initiatives from policymakers, particularly in the EU. A major theme today was the psychological impacts from digital technology products. How should these be identified, assessed, measured, managed in a product safety context? We heard a scientific viewpoint on how VR might impact brain function, and yet how different jurisdictions have different remits in relation to this in the form of harm, and the lack of standards for dealing with the impact of technologies like AI on mental health. It was also encouraging to see the wide range of different tools being used or developed to identify assess the digital technology product safety and health risks. Product safety regulators are considering how to assess the risks in their existing frameworks, but there's a lot to learn from work on standard setting and metrics developed in other areas, including AI incident monitoring tools. A couple of takeaways that emerged were the need for agile approaches to keep up with emerging technologies and the importance of a holistic approach to risk and impact assessment. It was furthermore great to hear from 4 different product safety regulators about their work on the ground, in relation to specific digital technology products. A key point here is how product safety regulators are starting to collaborate and partner with other regulators and stakeholders, and finding ways to adapt and respond quickly to risks from digital technologies through shared learnings. Finally, it was great to finish on a broader perspective from various experts on where things are going in the future. We heard about the rapid pace of technological change and long-term risks of AI, along with the challenges for traditional concepts in product regulation, but also about the potential for new principles-based governance and oversight frameworks to ensure safe AI. We heard that regulation and standards are struggling to keep up with the pace of change, but in a sense, that's always been the case. Although we now need to better collaborate to develop new and effective tools and methodologies, including to evaluate AI systems, or as metrology, as it was put, the science of evaluation. It was also good to hear some optimism from our speakers. The threats from new technologies are often the issues we hear most about, but it's clear that there are some promising opportunities from digital technologies to enhance product safety. I would like to give a very warm welcome thank you to the close on 20 excellent panelists we heard from today, including experts from government, the business community, academia, and civil society around the world. A big thank you also to the audience for the great questions that contributed to the discussions after the presentations. As I mentioned, this workshop is only the first step in a long project that the Working Party on Consumer Product Safety is embarking on, leading to a final report offering recommendations and best practices for regulators and industry to be finalised late next year. But as I mentioned at the outset, some of the interim findings will already be presented at a high-level meeting of OECD ministers on consumer policy in October this year. If you're a policymaker, a regulator, in business, academic or civil society organisations that would like to provide input to this project, or would like to follow the work and the work of the Working Party more broadly, please do not hesitate to get in touch with the Secretariat. Please write to Nicholas, whose address is in the chat box, nicholas.mcspedden-brown@oec.org. Thanks again, and I hope you really found today incredibly interesting, as I did. We look forward to hearing more from you in the future. Thank you very much.